Yes, so hi everyone. Very good evening to all of you. I hope I am audible. So let's get started with day number 3, the final day for this workshop from Geeks for Geeks on DevOps. So today we are going to cover Jenkins as well as Kubernetes, and we are also going to cover the practical. Okay, so the goal for this particular workshop was that I will show you an end-to-end DevOps pipeline, and then we will be deploying a full stack application on EKS cluster, or you can say on Kubernetes cluster. Okay, so let me share my screen and let's get started. So just give me a second. I hope I'm audible, right? Can anyone confirm in the chat box? Okay. Okay. Yeah. So just give me a second. Let me start sharing my screen. Okay. So in the last session, we were discussing about Docker, and we have also discussed what is this DevOps platform. And then today we will be discussing about Kubernetes. Okay, so I will give you a very quick, small revision of the last session, and then I will start ahead with the today's agenda. So till now, we are aware that what exactly is a DevOps pipeline, and then we have also seen in the last few sessions that if you wanted to deploy any of your application, okay, you want this application to reach to your end consumer. Okay, so this here will be my end consumer. Let's say the consumer will be in your production system. So you want your application to reach to your production system, to your consumer. So in that case, we have to follow a particular process. If we don't follow this kind of process, then we may deploy a bug related application to in front of our consumer, and that will be a very big issue because that's not a good way of deploying an application, and it's not a good reliability as well. Just give me a second, guys. I'm getting a call. Okay, I hope you guys can see me as well now. Okay, so our main focus is to take our application from our development environment. So your developers will be creating your application in the development environment, and from this development environment, we will take our application to our production system. So we faced a couple of issues over here. Then we have identified that we are going to create one pipeline, CI/CD pipeline, and with the help of the CI/CD pipeline, we will make sure whatever application we are deploying to in front of our consumer, that application is bug free, that application don't have any as such issues, and that application is reliable as well and good in performance. Okay, just give me a second, guys. I can see that again you guys are trying to draw something on my screen. Okay, so give me a second. Okay, and just one more second. Okay, so I hope now it should be fine. So that is our main agenda. So we discussed that the entire infrastructure we are going to achieve from AWS cloud. AWS is one of the public cloud provider. They are going to provide us the entire infrastructure. In top of this infrastructure, we will deploy our operating system, or we will create our operating system. And behind the scene, this AWS will be using virtualization technology. And via virtualization technology, they will be providing us this operating system. Once we have this operating system, in top of this operating system, we are going to deploy our application. Okay, that is a final flow. But the only manual approach which we are using over here was that once our operating system is ready, if you wanted to deploy your application, you have to first test your application. So in the last session, I have shown you how it can be done in a manual way. So I have shown you that we have created a virtual machine. Inside that virtual machine, I have installed the Python. After installing the Python, I have installed the Python pip manager. Okay, pip package we have installed. That is your Python package manager. After installing pip, we have installed all the Python related dependencies. So whatever dependencies you are using in your application, if you're using Python, you may be using Flask, or you may be using Dash, you may be using Pandas or NumPy or something. So all the dependencies you are going to install. And once your dependencies are being installed over here, then you may have to copy your entire code. That is a compulsory option. You have to copy the entire code which you want to be run. And then you may have to do some settings or configuration in your Python application as per your requirement. And then finally, you will run this command and your Python server will start. So we are doing these many things behind the scene, which will take some time because you are doing it step by step. And that's why scaling your application will be very slow. Why? Because if you wanted to create exact same replica of this particular server, then you have to again repeat the same process. And we don't want to repeat it. That's why we discussed about containerization technology. In containerization technology, what we can do, we can create all these steps one time, and then we can bundle this together. Okay, and we can call it as our image. Okay, and here we are using Docker as one of the containerization tool. So here we will call it as Docker image. Okay, you can also call it as Docker bundle, which we have created. What is this bundle? This bundle has everything which is required for your application to work. Or you can say it is a template you have created. Once you have this template created, now from this template, you can create or you can run your application without any issues. Okay, because you have the entire template ready. Just in a click, within a second, your container or your application or running instance of your code will be ready. And that's what we have achieved in the last class with the help of containerization technology. Okay, so if you go back to one of the repository, here in our GFG workshop 2025, you will see I have attached two more repositories information over here. Okay, I have also added some documentation. So whatever command I was running in Linux virtual machine in the last class, I have took the history of all those commands and I have put it over this file. So from this particular file, you will be able to find out all the commands which I have executed in my last class. So if you also wanted to replicate the same, you can do that. Okay, so you can find out the entire command history. Like these are the commands I was executing step by step. Everything you will be able to find over here. Then you will see for DevOps basics. These are some of the basic information about DevOps. Again, you can go with this README document and you can understand the topic. And then here in the README file, I have given you two repository link. This is one of the repository where we have hosted our Flask application. And this Flask application also had its own test file, test cases. So before deploying this Flask application, we were also running our test cases in the last class. Now we will automate it with the help of CI/CD pipeline. Okay, but in the last, we have also created one Docker file. And this is very interesting because this Docker file has our entire package. This Docker file has everything which is required for my application to run. Okay, so for my application, Python was required, pip3 was required. Okay, I have to install all the packages, dependencies of Python, that is also present. Okay, and then we have defined that it will be running in a port number 500, although it is mostly running in port number 5000. By mistake, I have used 500 over here. And then we discussed that can we please install or can we please perform all these steps while building my image. So building your image is a one-time process. Once your image is being built, you can share your image with other colleagues, other people. You can also host your image to Docker Hub. So we have seen that practical as well. I have logged into my Docker Hub account. In my Docker Hub account, I have uploaded this particular image. Now anyone who will pull this image and then they will run a container from this image, within a second, my entire server will be up and running. Similarly, I've shown you one practical for this Mario game as well. Okay, so this is one of the repository which has the source code for Mario game. Now, it's not the complete source code for a Mario game. Someone tried to replicate the Mario game in a via JavaScript. So in your web browser, you can replicate the game. So here, there's a basic code for on JavaScript. Client-side JavaScript is being used over here. So if you wanted to deploy this application, what we did, if you go back to Docker file, we are using Nginx as one of the base image. So Nginx server we are going to create. And then we are saying, Nginx server is saying that, can you please provide me all of your web pages, of your HTML, CSS, JavaScript file, which is required for your web server to run. So till now, whenever I was creating my web server, I was creating some very simple file, index.html file I was creating, right? So if you see, go back to this repository, I was using this index.html file. This index.html file just had a simple heading or simple paragraph. But here in this particular case, whatever data I have, that is complete HTML, CSS, JavaScript combination. And okay, all these data are present in this particular folder, Mario game. So we are doing a copy instruction over here. We are saying entire source code, can you please copy inside my Docker image? Okay, and in Docker image also, this will be copied at this particular location because your Nginx server will look for your web pages from this location. So we are copying it over here, and then we will say my application will be exposed on port number 80, and then we have started our application. That's what we did, right? So guys, anyone have till here? Any questions? Any questions specific to whatever we have discussed from last two classes? You can ask. Okay. Otherwise, we'll start with Jenkins over here. So I hope you guys are able to understand these topics. Can you please confirm? Okay. So because this is a base for today's practical. Okay. So Sarad, if you will start two Docker instance of Mario game, okay. So what will happen? Two process will start basically in your operating system. Okay. So in your operating system, two Docker containers you are running. These Docker containers are nothing. It's just like a process. Okay. So internally inside this container, your program will be running at port number 80 because we are using an Nginx server. Here also it is running at port number 80. But if you want someone from the outside world to connect to these particular containers, then you will have to do a port mapping. Because right now, as I discussed earlier as well, each container will have their own IP address. So this one will have their own IP address, let's say 172.17.0.3. This one will have their own IP address, 172.17.0.4. So until you are in your base system where you have installed Docker, okay, so you are in your base virtual machine. In virtual machine, you have installed Docker. Then in top of Docker, you have launched two containers with the same image. That is fine. But both the containers have their own different IP address. So if you are in your base image, sorry, base operating system, from here, if you wanted to connect to your server, you can do it. You can use curl command. You can use this container IP address and you can hit to port number 80. You will be able to connect to this container. If you hit on this particular IP address at port number 80, you will be able to connect to this container. But if someone who is outside of your EC2 instance, someone who is outside of your server, means your client, who is somewhere on the internet, if they wanted to connect to your application, so they can't directly connect to your private IP address. They will have to connect to a public IP address. And in this case, they will connect to public IP address of your EC2 instance, your virtual machine. Your virtual machine or the operating system, okay, will have a public IP address. This public IP address will be in range like 200.6.4.3, whatever range. So he is going to connect on this particular IP address, but once he will reach to your operating system, this is your operating system. In operating system, hundreds of processes are running. How your kernel will decide in which process I should divert this particular request. That's why here you will have to do a port mapping. You will say anyone who will come to your base operating system, anyone who will come to me at port number 81, any port number you can do. So now this port is open on your operating system. So we are saying anyone who will come at port number 81 of my base system, he will be mapped with, or his request will be proxy to my this particular container. And anyone who will come to my public IP address at port number 82, for example, then he will be mapped to this particular container or this particular service which is running over here. And we can't have two processes mapped with same port number. It's not possible. The same example, like in an apartment, we can't have two flat with the same number. Okay, that's why we will have to do port mapping over here. Okay. So Prashant, just wait for a minute. Let me first complete Jenkins. Once I will complete Jenkins, then when I will be showing you the end-to-end project, then you can try doing it. Okay, we haven't started Jenkins yet, right? So let me start Jenkins. I hope Sarad, your question is clear. Right. Anyone else have any doubt? So now we have a very limited serious students in this particular class, because from last 2 days we were seeing that a lot of people were doing spamming over here, right? So we have removed all of them to make our experience better. Okay. So let's get ahead and let's learn more about our CI/CD pipeline. So I'm going back to my AWS cloud. Here I'm going back to my EC2 service. And today I'm going to launch one more EC2 instance. And then in this EC2 instance, I'm going to perform some kind of setup. So I will launch it. Okay. So by now, if you would have done some practice after the classes, so you will be aware how to launch EC2 instance. The steps are very simple. We will have to give a name, let's say GFG server 1, for example. Okay, then which image file I will use. So let's say I will go with Amazon Linux once again. which instance type, you can go with T2.micro, but because I'm going to configure or run a Jenkins server over here, so I will recommend you to go with T2.medium, because T2.medium instance type will give you 2 core CPU and 4 GB of RAM. T2.micro is giving you only 1 core CPU and 1 GB RAM, which is fine for your basic practicals. But if you wanted to run a Jenkins server, it will need more RAM and CPU. So I'm going with this particular instance type. And now this instance type is not under free tier. So if you use it, you will have to pay. That's why what I will recommend, that if you want to do this practical, do it. Once your practical is completed, delete it. Okay, so if you use it for a certain duration of time, they will not charge you. But if you keep it running for a long duration, then they will start charging you. Okay, so I'm going to use T2.medium because I will have a better performance. I will have 2 core CPU and 4 GB of RAM. Okay, and then in the key pair, I will select any key pair which I have created. I think the key pair which I created in the last class was something like GFG workshop. This key pair I'm going to select. And in the network settings, guys, I'm going with all the by default right now. And in the storage, I will say 8 GB should be enough. But let's say I will give 15 GB of SSD over here. Why I'm giving more hard disk? Because today we are going to do a lot of setups over here. So I want a better performance. I don't want my system will start getting hanged. So that's why I'm giving some more resources over here. But if you will go with 8 GB, 8 GB will also be enough. Okay, so from my end, I'm going with 15 GB to make it more better. So more storage I'm giving to my EC2 instance. Okay. So Sadat, first of all, these two are not instances, they are Docker containers. So if you want to do a port mapping, so what we did in the last class, the command was Docker. Whenever you use Docker run command to run a container, we have an option -p over here. This -p option is doing the port mapping for you. This is the one which is doing the proxy for you. If you remember, we were doing something like this. Port number 80, let's say port number 80 means anyone who will come to my base system at port number 80, he will be mapped to port number 80 of my container. Or you can say port number 8080, column port number 80. This is the port mapping. When you launch your container, if you pass this particular argument, then the port mapping will be done. Nothing else you have to do. Okay. So now you can see my instance is getting ready. Let's log into this instance. Let's connect. What happened? Yeah, let's connect over here. So I'm directly connect on this particular web UI. Okay. What next thing we will do? Once our EC2 instance will be up and running, I will log into my root user. Okay. And then we are again going to install Docker, yum install Docker. So I will need Docker in today's class as well. So I'm going to install Docker. And once Docker will be installed, now we are going to set up Jenkins over here. Okay. So if you want to know more about Jenkins, go back to your browser, search for Jenkins. So let me go back here and search for Jenkins. Okay. So you will see this is the official website of Jenkins, and Jenkins is open source, guys. Okay. So there's a very great community which is working behind Jenkins. Okay. So it is open source, but they are providing you an automation server where you can automate everything. You can create the entire CI/CD pipeline. Okay. So they are saying it is very easy to install Jenkins. It is very easy to configure Jenkins, and Jenkins has a very great integration with all different kind of tools. So you can integrate Jenkins with Kubernetes, with Docker, with Git, with SonarQube, with almost all the tools Jenkins can be integrated. You can see here they are telling it is for continuous integration, continuous delivery, or deployment. You can say Jenkins have a lot of great plugins. So these plugins are the one which helps your Jenkins to integrate with other kinds of programs or tools in the market. Okay. So if you wanted to create Jenkins server, you can install this Jenkins directly into your Windows system as well. You can install Jenkins in Linux as well or Mac as well. Okay. But again, in real world, we will be using Linux only. So in this class as well, we are going to see how Jenkins server can be created on a Linux operating system. In Windows also you can do for testing purpose. But if you wanted to have a real world kind of feeling, then please do it on Linux operating system. Okay. So this Jenkins is built on Java. Okay, so this Jenkins is written on Java, you can see. So Java programming language they are using behind the scene. That's why if you wanted to install Jenkins, what you will have to do, you will have to first install Java JDK in your system. Okay, once you install Java JDK in your system, then you can install Jenkins program. Once you install Jenkins program, then you will have to install some of the dependencies of Jenkins as well, and then you will have to do some further configuration over here. Okay, so just for installing this Jenkins server, we have to perform so many steps. In our base system, we must have a Java support, we must have a Java JDK installed, Java development kit. Okay, and then we can install Jenkins. Okay, so once we have this entire configuration ready, I can say my Jenkins server is up and running. Okay, that's what we will be doing. But you can see, if I wanted to configure Jenkins directly on my virtual machine, I'll first install Java JDK. So many things I will be doing. So to make it simple, what Jenkins community people have done, they have also created one Jenkins Docker image. Okay. And they are saying that if you wanted to create Jenkins server and you don't wanted to do all these things step by your end, okay, then you can directly use this particular image which I am giving to you. This, as you will download this image or pull this image, and from this image, as you will create your container, that container will have your Jenkins server running. You don't have to do any much configuration from your end. Okay, so this is like they are again giving me an image. In that image, they have put everything which is required for Jenkins server to work. Okay, so we are going to pull that image, and from that image, we are directly going to create our Jenkins server. Okay, otherwise, if you want to do directly on your base system, you have to follow a process. If you want, I can share you some additional document for that. But right now, I will be again utilizing the power of Docker over here. Okay, so if you remember in the last class, we were doing one practical, and we said Docker. In Docker, we have a Docker registry. This is a registry hub.docker.com where you will find all different kind of images. Even you can create your own account, and you can also push your images. Okay, your application images, like one of the image GFG sample image we have pushed in the last class. So here I will search Docker. Do you have anything for Jenkins? Okay, Jenkins. Okay, so Docker will say, yes, I have one image available for Jenkins as well. If I search, you can see this is the image, Jenkins. And this image, again, they are saying it is by Jenkins community only, the leading open source automation server. Okay, and they have more than 1 billion downloads, means we can rely on it on this particular image. So I'm going to launch my Jenkins server via this image. If you want to create a Jenkins server, you can directly install it on your base system, your virtual machine as well. Okay, directly. But I will be using Docker over here. So I will first pull this particular image, Docker pull Jenkins/Jenkins. I will pull this image. Okay, I will go back to my EC2 instance. Where was my EC2 instance? Here is my EC2 instance. I will start my Docker engine because I have just installed Docker. I haven't started it yet. So I will have to start it. Then only it will start working for me. And once my Docker engine is started, now I'm going to run this particular command. So this command is going to pull my Jenkins Docker image from my Docker hub to my local registry, to my local virtual machine. Because once you have this image pulled into your local machine, then only you will be able to launch some containers. Okay, so I will do Docker images. So what you will see, my image is currently being stored in my local registry. Okay, and this is my centralized registry, which I was using earlier. From here, I have pulled this image. So what it will do for me, it will help me to do a continuous integration delivery server. So it will help me to create a continuous integration pipeline. Okay, they are saying you can pull these images, and then they have also attached one documentation. If you click on this documentation link, it will open the official repository of Jenkins. As I mentioned, Jenkins is open source. So from this repository, if you wanted to do any open source contribution, you wanted to contribute something on Jenkins, you can do that. This is the entire repository which has a source code of Jenkins, how exactly Jenkins work behind the scene. Okay. So right now they have opened a README file. From the README file, they are giving me the command, Docker run command. Okay, and this is the port mapping option -p. Okay. So here you can see they are giving me the port mapping option. They are saying if someone from the outside world wanted to connect to your Jenkins server, okay, so they can come to your base system at port number 8080, and they will be mapped to 8080 port number of your container of your Jenkins server, because Jenkins server usually runs at port number 8080. So you just have to copy this particular command, and you have to go to your EC2 instance, and we can run this command over here. Okay. In this, I'm going to add a small step. Okay. So I'm just going to give a name as well to this particular you can say container. I'm going to give a name, let's say Jenkins as one of the name. Okay, and then I also wanted to run it in detached mode. So I'm using -d option to run in detached mode. If I don't run in detached mode, so it will run in foreground, and it will eat up my entire terminal. Entire everything will be open. All the logs of this particular container will be open in front of me, and I will not be able to use my terminal. So I'm running in detached mode, but I also wanted to have an interactive terminal so that I can go inside this particular container. I can get the terminal of this container. That's why I'm using -it over here. Okay. As I will run this, you can see in a second. Okay. I think I have pulled the wrong image last time. So whenever you try to pull an image or anything, if you don't give any tag, then they will pull always the latest. They will automatically consider you are talking about latest tag. But in this case, I am using one of the tag called is LTS. LTS means long-term supported version. So what my Jenkins people have done, because they will keep on updating their Jenkins server, they will keep on updating their repository, their code. Okay. So what they have done, they have marked this particular version of Jenkins as LTS, long-term supported. Means they are saying that this particular version of Jenkins is properly being tested by so many communities, and we have got always a positive result. So they have tagged it as LTS version. Means you can rely on this version. This version will it's very less chance that this version will have any bug and all. Okay, because whosoever is a developer of Jenkins, basically it's a community. What they will do, they will keep on uploading, they will keep on pushing the new changes. You can see just 7 days back they have updated this particular image. So in the newer version of this image, they might have some bug, or it might be in beta phase. They might be testing it. Okay, so LTS is one of the version which you can rely on, which is properly being tested. So if you just check the tags, so many tags are currently available. We are using, let's say, this one, or I can use some other as well. Okay. Now, once my container is ready, if I do Docker PS, you will see my container is right now running, and they are saying anyone who will come to my base system, my virtual machine at the public IP address. This is a public IP address. I will copy this IP address. Okay, hit it over here. And anyone who will come over here at port number 8080, okay, you can see here is mentioned 8080. Then you can see there's an arrow icon over here. Means anyone 0.0.0 means anyone in this world comes at port number 8080 of my operating system, then they will be mapped to my container. In my container, the program is running in 8080. So as I will hit it, I will be able to connect. But you guys are aware, my security group will again block me. So let me go back to my security group rules and let me allow this particular port number. So when I select this instance, I will go to security section. I will go to my security groups and I will allow this particular traffic. Okay. And then I will click on edit inbound rule. And guys, let me do one thing. Let me allow all the traffic. So in the last class, you would have seen that I was updating this particular security group so many times, right? So if you don't want to do it, let's say for testing purpose, we are in development right now. You can allow all the traffic to your EC2 instance. Just for now, in production system, we don't do it. In production system, we allow only those traffic which you think are important. Okay. So you will have to keep updating your rule. Right now, just to make it simple, I'm allowing all the traffic and I'm clicking on save the rules. Okay. Once it is done, if I go back, you can see it's now I'm able to connect, and they are saying your Jenkins server is ready. Jenkins will give you a web UI. From this web UI, you can manage the entire Jenkins server. And they are saying that if you wanted to use this Jenkins, first of all, you will have to prove your identity. And for proving your identity, they are saying in the Docker container which you have just created, in that Docker container, there is a file which is stored at this particular location, var/Jenkins home secrets and initial admin password. And at this particular location, I have given some initial admin password. If you give that initial admin password over here, then only I will let you proceed. And then they will give us a prompt as well to update the password. So this is, you can say, a by default password which has been set. Just to prove my identity, I will have to give the initial password. And if I give the right initial password, then only they will let me go ahead. And then only they will let me proceed the installation of Jenkins. So I will have to go to my container. In this container, I will have to find out the content of a file located at this particular location. So I will copy this, okay, and I will go back here. Now you can see my container is running, right? In this container, if you wanted to go inside this container, then what will happen? So let's say if I say Docker, I wanted to attach to a container. We discussed about attach command. So if you have a container which is in running state and you wanted to attach to the program which is running inside that container, we can use attach command. And then I can give my container name or my container ID. In this case, my container name I have given as Jenkins. You can see Jenkins as a name. So as I will do attach command, you will see one. And this is very important concept which you need to understand in Docker. Okay. Whenever you use attach command, what it does, it attach you to the program which is running in that particular container. In this case, in my container, there was some Jenkins server program maybe running. So I have been attached to that particular program. But I wanted to attach to a bash program because bash program is the one which gives you a terminal. From the terminal, you can run some command, ls command, create command, and all these stuff. So attach command will only take you to the command which is running inside that particular container. To give you a demo, you can see these are the things. I'm just pressing Control C right now. If I press Control C, so what you will see, whatever command I was running, okay, it was closed. I did Control C, it was closed. But because while launching this container, I have added one tag that whenever there will be a failure, you can restart the container. You can see hyphen restart equal to on failure. So as I did Control C, my container was stopped. But as it was stopped, my Docker have again started. You can see just 5 seconds back, Docker have started it. Okay. So let me show you this particular command, attach command, what it does. So if I create one more container, Docker run, let's say -it, okay. And then if I use Amazon Linux, for example, this is the image I'm using right now. As I will enter, this image is not present. So they will first pull this image for me. And from this image, they are going to create a container. Okay. So you can see as this container was created, they took me to the bash shell. Why they are taking me to the bash shell? Because in this particular image is providing the bash program as one of the output. Jenkins was providing their Jenkins server. My Python image, which I have created in my last class, okay, if you go back, the Python which we have created, it is providing you a Python server as output. It's not providing you a bash program. Okay, so attach command will always take you to the command which is running inside your container, the main command which is running inside your container. So if I will try to come out from this container with a escape sequence, Control plus P plus Q, okay, we have discussed about it. And if you see Docker PS, now if I do Docker attach and attach to this container, whose name is amazing, something like that. They have given some random name. Let me copy this and paste it. So you can see they have just attached me because in this particular container, bash program was running. So they just attached me to that particular program. But in case of Jenkins, they are not running any bash program. They are running something else. They are running some Jenkins server. Okay. And here I wanted to go inside this particular container and I wanted to go inside this container because I wanted to execute some command. So I will need a bash program. So how can I do that? So for this, you usually have one more command that is called as Docker execute command. So whenever you wanted to go inside a container and you wanted to execute something else, some other command other than the main command which is running in that container. So instead of you using Docker attach, you should always use Docker execute. Because whenever you use Docker attach command, it will always attach you to the main command which is running in that container. As a Docker, I wanted to go inside this particular container whose name is Jenkins, and I wanted to have an interactive terminal because I want a bash program over here. And then they will ask me which command you want to run inside this container. Do you want to run ls command in this container? You can see as I do this, it will go inside this container, execute the ls command, and then come out from that container. Okay, then they are saying what command? Do you want to run any kind of pwd command which will show you your present working directory? So what it does, it went to my container, executed this command, and then come out from the container. But in my case, I want to run a bash program. As I will run the bash program, you can see now I got a terminal of my Jenkins server, okay, which is running. So in my Jenkins right now, their server is also running. This is a command, okay. But I have opened one more command, one more program, one more process, that is your bash process, and this bash process is going to give me or provide me the terminal of this particular container. And here I wanted to execute cat command. Why cat command? Because this is a file where they have stored the initial admin password. I want to read the data in this file. I will use cat command to read this file. As I will read, you can see this is the initial admin password they have set. I will copy this and I will give it over here. And then I will say, Jenkins, this is the initial admin password which is being set. And Jenkins will say, you are giving me a right password. That's why they will let me sign in, or what happened. If I'm not giving a right password, they will, okay, now it worked, right? They let me sign in over here. Then the next step is Jenkins asks that do you wanted to install some plugins? Okay, so either you can decide what kind of plugins you want to install, or some community people have already selected some mostly used plugins. Okay, these are called as suggested plugins. These are the plugins which are mostly used by the community. So they are saying, do you want to install plugin by selecting by yourself, or you wanted to install all the plugins which communities have found helpful. So let me go with install suggested plugins. So it will install a couple of plugins for me. Now, what is this plugins? These plugins are the main backbone of your Jenkins. Okay, because Jenkins is an automation server. The only work of Jenkins is that Jenkins will need to communicate with other programs. Let's say here Jenkins will need to communicate with GitHub, because I want, as my developer will push the code to GitHub, my Jenkins should know that there is a new code in my GitHub. Jenkins should automatically pull that code, and Jenkins should start doing the testing of that. Then I want Jenkins to build a Docker image for me. Or I want Jenkins to connect with a SonarQube server, which will do an analysis of my code. So again, Jenkins will need to connect with SonarQube for that. SonarQube is a separate server, guys, which helps you to identify the quality of your code. Similarly, I want Jenkins to connect with Docker so that my Docker image can be built dynamically. Last time I was building Docker image manually. I was using Docker build command and then I was building it. But I want, as my testing will be completed, automatically my Docker image should get built. I don't have to do it manually. So again, Jenkins will need to communicate with Docker as well. In future, Jenkins will need to communicate with your Kubernetes as well. So these all are different tools. Like that's why DevOps is called as umbrellas of tools. Okay, umbrella of tools. So DevOps has so many tools. Now, if you want to integrate all these tools, then you can do it via Jenkins. And why? Why? Because we want to create a seamless pipeline over here. Okay, we want to have an integration of them. Okay, so by default, Jenkins don't know or don't have support for them. But with the help of plugins, Jenkins got to know that, okay, how to communicate with a particular program. Let's say here, you can say Git plugin is getting installed. Jenkins will know about Git plugin. Jenkins will know about email. So let's say you want, whenever I'm running a pipeline, if my pipeline failed, I should get an email notification that your pipeline was failed. So you will need to install this email plugin over here. So as per your requirement, you will keep on installing the plugins. Okay. The next thing is they are asking me to set up my own username and password. Okay. So now I will set up my own username and password, and this password I'm going to use further. Okay. As a test@gmail.com. I will click on save and continue. And that's it. My Jenkins is now ready. I can start using my Jenkins. Okay. So that's what we have done. This is the exact web server which Jenkins is going to provide you. Okay. So I can see in the chat someone is saying that you got some cost. Okay. So you can connect with me regarding that separately. I will give you a format for email, and that email you can send it to AWS support team. They will help you to fix it. Okay. Siddhant, I'm not sure if there is a meeting mail not being sent by my team. I can check with my team. I'm not aware about it. So for 2-3 hours, it would be very minimal Ayush. You can just imagine it would be 100, 150 rupees, something like that. Very minimal. Okay. Okay. So, okay. So you are saying you don't understand what Jenkins do. So if you were there in my last class, you will remember what I was doing with the my manual setup was, once your code is being developed by your developer, I was saying that we have to test this code. Okay, we have to check the quality of the code. Okay, and for each, these are the individual steps which I wanted to do one by one so that I can prepare my code for the deployment. Then I was saying, once the quality is being done, please check the linting of the code. Okay, linting means whether the code is following all the Python standard or not for writing it. Similarly for Java standard or not for writing the code. Then we were saying that once your code is ready, now I can try to bundle my application so that I can further deploy my application. Okay, so for bundling it, what we discussed, we are going to use Docker over here. So we are going to create one Docker image which will bundle my application, everything which is required for my application to work. I will bundle it, and then this bundle I am further going to use for the deployment purpose. Okay. So right now I have just mentioned very small steps, but in real world there will be so many steps you have to do one by one. Okay. So if you want to do a testing, what will you do? Before testing, you also have to do one thing. You have to install Python. After installing Python, you have to install your pip. Then you have to install all your dependencies. Okay. Then after installing dependencies, then you will do the test. So you can see now we have so many steps. I was doing all of these steps manually over here. But you imagine in a team where you have hundreds of developers working on the same project and they are keep on updating their code, is it possible for a human being to do these many steps manually every time? It's not. That's why we are using Jenkins to integrate all these steps or to put all these steps over here. So Jenkins will automatically do this. I will show you a practical, then you will get a more idea about it. Okay. So Sarath, wait for some time. Let's see a practical with Jenkins, and you will get an option. Okay. So you will get to know what Jenkins is doing. Okay. So once my server is ready, you can see my Jenkins server is now ready. I am going to click on new item and I'm going to say Jenkins, I wanted to create a pipeline over here. I will say Python pipeline over here. And then I will select my type as pipeline. I wanted to create a pipeline. Pipeline means you will have multiple steps and you want to integrate all these steps. So I'm going to select pipeline. Okay, just select this option. Once I will show the practical, everything will be clear why we are using Jenkins. Okay. Now Jenkins will give you so many columns or data over here. Just ignore them right now. Okay. We will come to them one by one whenever it will be required. Okay. Now here we have to give a Jenkins. We have to give a Jenkins pipeline script. Okay. We have to tell Jenkins, I want you to do a couple of things for me. Okay. So I'm going to write a script over here where I will tell that please download the code for me. That's the first step. Then please here also you can see we are getting a template. Okay, so whenever you want your application to reach to your deployment or to your server, you are following a process over here. So you are documenting all this process into one file. Okay, that is called as your pipeline code. Okay, pipeline as a code you can say. In this code, I will say Jenkins, what you need to do first, you need to install Python, then you need to do install pip, then you need to install all the dependencies, then you have to perform test cases, then you have to check the quality, everything I will mention one by one to Jenkins. So for that, Jenkins have their own syntax which Jenkins understand, and that is called as Groovy. Jenkins understand Groovy language over here. Okay, and you don't need to worry much about Groovy. Groovy is very similar to JSON. In JSON also, what happened? We have curly braces. Okay, we have curly braces. We have a key. Okay, we have a value. Okay, similar kind of format here also we will be having to create our pipeline script. This is your pipeline script which I am going to create. What I will define this pipeline script. So you can try a sample pipeline like a hello world pipeline. So in this pipeline, this is how your script will look like. Very simple. The first thing is I'm saying Jenkins, I wanted to create a pipeline over here. So this is just a comment I'm adding. This particular keyword means I wanted to create a pipeline. Okay. Then in this pipeline, there will be multiple jobs. So these stages or this stage keyword which you see here, this means that you will be having multiple multiple work you have to do. Okay, and all these work you are integrating together. That's why I'm putting them over stages section over here. Okay, and what is my first job? Okay, so my first job is, let's say I wanted to execute one command. Echo means in Linux, usually echo is used for printing something on your screen. So right now, echo means it will print hello world in your screen. Okay. So here it is going to print hello world in your screen whenever you run it. Okay. So let me run this simple pipeline over here and let me click on save and let me click on build now. Okay. So what will happen if you click build now? Jenkins is going to execute your pipeline. Whatever you mentioned, Jenkins is going to execute it. And you will see Jenkins have executed my pipeline. Okay. And right now, if you click on that pipeline, go back to your console output, means output of the pipeline. Jenkins will say, I have printed hello world for you. That's what you wanted. I have printed hello world for you. Okay. Now let's say I will say Jenkins, don't just do hello world. Now I want you to take my code from my repository and then perform end-to-end pipeline I want you to create. I want you to perform end-to-end testing of this code. I want you to perform everything which is required for my application to move to production system. So pipeline or Jenkins is the heart of DevOps. Very important tool you can say for DevOps. So you tell me if you have a repository, let's say this is my repository, this is my Flask application. If I want this Flask application to be deployed on a server, currently it is on a GitHub over here. My developers have created the code, you can imagine, and currently it is on GitHub. Now I want to deploy it on server, so I can't directly deploy it on server. That's what we discussed on the day number 1. Okay, so I have to follow a process. So I will copy this URL from here. Let me just copy it from here. And I will say, Jenkins, can you please do one thing for me? Can you, first of all, download this code? Okay. So I will say, download the source code. Whatever I am writing over here, this is just a sample string which will help you to identify what exactly your step is going to perform. Okay, so I'm saying Jenkins, do one thing. I want you to make my code ready for my production deployment. And if you want to do it, the first thing is you have to download the code, because once you download the code, then only you will be able to test that code. Then only you will be able to check the quality of the code. Then only you will be able to run that code. First step is you have to download the code. Okay. Then here I will say Jenkins, I want to download the code from my GitHub repository. Okay, so here in your Groovy syntax, Jenkins have a way where the Jenkins can clone your repository. Okay, download your repository. Okay, if you want to see the exact syntax, you can click on the pipeline syntax. This will help you to create a pipeline, because right now I'm going to create this pipeline manually. Everything I'm going to write one by one over here. But usually this pipeline syntax can help you to write your pipeline more frequently. Okay, let's say if you wanted to clone a repository, I wanted to clone a GitHub repository. So I will say Git, do you have anything for cloning a repository? So Git has one keyword Git over here. Select this, then Git will ask you. This is like a simple UI they are giving. If you just fill in all the details, they will convert this particular data into a pipeline script. So if you don't want to run a pipeline script by yourself, okay, then you can use this kind of pipeline script generator. Here you can give, they are saying, what is your repository URL? I will say, this is my repository. You can copy your repository link from your GitHub. This is my repository link, which I have copied. And then they are saying, what is your branch name? In which branch do you have your entire code? So in GitHub, you can have multiple branch. Right now I have branch main. In main branch, I have all the code. Okay. So I will say I have a branch main. And then I will click on generate pipeline script. So this is like your pipeline script generator. And you can see they have given me a script as it over here. They are saying copy the script and put the script in your over here. Paste this particular script. What it will do, it will clone your repository. It will download your repository. Okay, so this is the first thing which I am going to do. That is cloning the repository repo. Okay, once the cloning of the repository is done, then I will try to do my next step. What will be the next step after cloning the repository? So I would like to install Python in my system, because if I don't have the Python, how can I test it? Okay, so these are the same things which we did in our last class manually. So if you go to my workshop GitHub repository over here, if you go to command history, and if you see what commands I have executed in my last class to test everything, you can see the first thing I did was cloning the repository. After cloning the repository, what I was doing, I was installing Python, then I was installing pip, a lot of things I was doing behind the scene. Same thing I can repeat over here as well. Last time I was doing these things manually. One time I can do. But what if my developer has made some changes in the repository? So same steps I will have to again repeat. And for a human being, it's not possible. It will be very slow. That's why we are using a tool over here. So I will say once you have downloaded the source code, the next step what you need to do, Jenkins, is you need to, let's say, install Python 3, for example. These are your job number 1. This is going to be my job number 2. You have to use curly braces to define that till from here to here, the code is for my job number 1. In one job, you may perform more than one step. This is my first step, which I'm writing. Means only one thing only one job, only one work I am doing in this particular job. What is my second job? My second job is to install Python. Okay. So let me write install Python. Once my Python is being installed, I'll say what is the step? How to install Python? They will ask me. So I will say I will write a step over here, and I will say if you want to install a Python, you will have to run one shell command. Okay, so you can go back to your pipeline syntax generator. You can say pipeline syntax generator. Do you have any way to run a shell command? So they are saying if you want to run a shell command, means terminal command bash shell command. So they have an option sh shell script, and they are saying what exact command you want to run. So I want to run command yum install Python 3, for example. Okay, I will click on generate pipeline script. They will give me a script right now. This is a script. What this step will do, this step will install Python for me in the system. After installing Python, what will be the next step? Okay, the next step is once my Python will be installed. Okay, the next stage which I am going to create is please install my pip as well. Install pip. Okay, so whatever we did last time, I'm just putting everything in this particular file so that I don't have to perform these steps again and again whenever my developer update the repository. Now this will be this will be already or automatically get executed. So you are just creating one script. So all these steps will be automatically executed from the next time. Okay. How to install a pip? Again, you will have to give the exact command. Okay. So my command will be, again, I will say steps, and then I will say, I will run here that I wanted to install yum install pip. Okay. So my pip will be installed. Once your pip is installed, what is the next step you have to do? You have to install all your dependencies. So again, I'm going to write my second or you can say fourth job, and my fourth job will be to install Python dependencies. Okay, and then I will mention that I wanted to install this Python dependencies. How many steps do I have over here? So I have one of the steps. Okay, to install Python dependencies, the command which I was running in my last class as well. This was the command pip3 install -r requirement.txt. Okay, so I can copy this exact same command and I can paste it over here. So whenever you run a shell command or you want to run a shell command in this particular Jenkins from a Jenkins pipeline, you have to use sh keyword over here to denote or to define. I wanted to run a shell command over here. I'll say sh and then I will give the exact command. This command is going to install all the dependencies for me. Okay. Once my dependencies are installed, what next I was doing? I was running my test cases, if you remember. Okay, so after this command, last time I was running my test cases. I was running this command. So I will say Jenkins, what you will do after this? Okay, you have to run one my test cases. So I will say execute test cases. Okay, and then I will say what is the steps, how to run the test cases. Okay, so Jenkins, I have to inform Jenkins that if you are run a test cases, then you will have to run a command, pytest command. This will automatically execute the test cases. So we have already done half of the work. We are just running the test cases. After that, we have to also build my Docker image, and then I have to also deploy my container. But till here, let's see how exactly it's going to work. Okay, so I have created my pipeline script. Now, as I will click on the save button, and now I will click on the build now button, my pipeline will be triggered. And you can see this is being triggered for the second time right now. Okay, and what you will see, if I check, it got failed. Whenever your pipeline got failed, it means there is some issue either with your pipeline script or the command which your pipeline is trying to execute. And if you scroll down, what your pipeline does, you can see your pipeline is have performed all the steps one by one. The first thing what pipeline does, it started cloning your repository, cloning the remote git repository. Means they have first cloned my repository. After cloning my repository, they were trying to execute this particular command, yum install python 3, and got failed. They are saying yum command is not found over here. So I was trying to run this particular command. Okay. So here they are saying this particular command, yum command is not found, your package manager is not found, and that's why this command got failed. And because this command was failed, this particular job was failed, so all the other next job were skipped. Because my earlier one is failed, so it won't make any sense to execute next jobs because all of them needs to be executed in a sequence over here. Okay, so this particular command is saying yum is not found. And what is the reason behind that? The reason is by default, my pipeline was getting executed in my Jenkins server, which I have created. So this is a Jenkins server I have created, which is running inside a container, right? This Jenkins server don't have yum as the package manager. It is built via taking Ubuntu as a base image. So it don't have yum command present. That's why whenever you will try to use this particular Jenkins server to run any of the Linux command, will not work because whenever you are trying to execute your command will be executed in a particular compute place. In this case, this command was getting executed inside my Jenkins server, and in my Jenkins server, because that particular command was not present, it is getting failed. Okay, so if we wanted to fix it, so what we can do, we can go ahead with Jenkins multi-node cluster configuration. So guys, whatever questions you are getting right now, I can see a lot of questions in the chat box. I will explain it. Just let this particular practical complete. Your whatever questions you are asking, it will automatically be answered. Okay. So once this practical one, once our pipeline will be completed, you will automatically get to know about your questions. Okay. So we have to now identify that Jenkins, you are running everything on yourself, okay, and you don't have right now YAML installed, and that is causing the problem. Okay. So this is called a single node cluster. Single node cluster. Why single node cluster? Because I have only one node over here, only one server over here, which is working like my Jenkins server, okay, which is the one who is taking all the instructions from me, and this is a server which is also executing that instruction. Okay. But if you wanted to distribute the load, because if you just imagine, right now I am the only one who is triggering the pipeline. But in real world, for your entire organization, you are working in a company, for your entire company, there will be one Jenkins server running. Okay. In your company, there may be hundreds of different projects people may be building. Okay. Some of them may be working on a different project, client project. Some of them may be working on different client project. You have one Jenkins server, but there are so many projects where different teams are working in your company. In that case, whenever any of the developer will make any changes, the pipeline will be triggered. Their respective pipeline will trigger. For every project, there will be a separate pipeline. But because I have only one single Jenkins server, so everything will be getting executed on this particular Jenkins server. This Jenkins server will have a huge load over here. And if you want to distribute a load, then you can go ahead with multi-node cluster. Jenkins multi-node cluster. In multi-node cluster, what happened? We can create some more worker nodes, some more slave node, you can say. And what these slave node is going to do, they are going to divide some of the tasks what Jenkins is doing. Okay. So in my Jenkins, the system where your Jenkins server is running, it is also called as master node. Master node. So master node is the node where your Jenkins server is running or where your main program is running. In this case, Jenkins program is running. Okay. So in that case, this particular container, because my Jenkins is running right now in a container, so I will say this container is like right now working like a master node. And usually master node is the one who manages everything. Okay. In master node, we usually don't execute the jobs. Like here, I created one pipeline script. And then when I was executing this pipeline script was getting executed in my master node itself, which is ideally not a good thing. Your master node should be doing only one task. Like your master node is providing you this kind of web interface. Master node is providing you the options to create pipelines, to trigger the pipelines, to log out from the account or to create a new account, to install the plugins. These are master jobs, master jobs. Okay, master work, you can say. But whenever you want to execute a pipeline, so while executing a pipeline, I have to perform so many steps, right? I have to install dependency and everything. These things will need some computing resources. For this one as well, if you are using the computing resources of your master node, so your master node work will be impacted. That's why here we create a multi-node cluster over here, and then we will create multiple worker nodes. Okay. And what these worker nodes will do, these worker nodes will be responsible for executing your pipeline jobs. So whatever I have mentioned in my pipeline, these things will be executed on your worker nodes. Master node is only managing everything. It's not executing the job within itself. It's executing the job on your worker node. Okay. So that's why now I will create one more system, one separate system you can imagine. Okay. And in that system, okay, in that system, I am going to execute this job, execute my job I have created. And for this, in this particular system, you will have to create one agent. You have to start one agent, because then only your worker node will be able to communicate with your master node, and your master node will be giving all the instructions to your worker node. So once I do the setup, the process will be, I am the DevOps engineer. I will create my pipeline as a code. Okay. I will create my pipeline as code. In the pipeline code, I will define everything what I want my pipeline to do for me. Okay. So whatever I want my pipeline to do, everything I will define this particular code. Then I will trigger that pipeline. Okay. Trigger that pipeline. As I will trigger that pipeline, my Jenkins is going to acknowledge my request, and then Jenkins is going to send a request to one of his agent, whosoever will be available at that point of time. They can distribute the load as well. Jenkins will decide everything. Jenkins will say, I have been triggered to execute this pipeline. So Jenkins will send everything which needs to be executed to this particular agent. And this agent is the one who will listen from the Jenkins server, and then it will execute over here, execute everything on that particular worker node. Okay, so let me configure one multi-node cluster of Jenkins, because in real world, everywhere you will see there will be a multi-node cluster. Okay, so I will go back to my AWS EC2 instance. In this case, to configure a worker node, what I will do, I will launch one separate EC2 instance. Okay, one more EC2 instance I'm going to launch. I will click on the launch instance button. Okay, I will say this is going to be my Jenkins worker node. Okay, all the Jenkins worker process is going to be executed on this separate system. And if your company is big, you are running more pipelines in a day, you can launch more and more worker nodes. Okay, as per your requirement. Here again, I'm going with toward medium, but you guys can still go with toward micro if you want. Okay. And then in the key pair, I can again use the same key pair I used last time. TFG workshop. In the network settings, guys, you may allow only this particular traffic, but let's say I wanted to allow all the traffic. So what happened whenever you select a security group of firewall, by default for every EC2 instance, they create a new security group, a new firewall. But you may also attach an existing security group to your EC2 instance. I will show you that later, but let me just go with create security group for now. Okay. And then I will do one more thing. I will go with, let's say, 15 GB of storage as well. And I will launch this instance. So one more EC2 instance I am launching right now. Okay. And this is in this EC2 instance, I am going to configure it as my one of the worker node. Okay. Of Jenkins. So I said, Jenkins, you don't do all of your job within yourself. Okay. You can perform all of the jobs in this particular worker node. So we are not creating another worker node, James. This is the first worker node we are creating. What is a worker node? Worker node is the system where your jobs will be executed. The one which I created earlier was my master node, because here my main Jenkins server is running. Master is your mind, your brain. Here exactly my Jenkins server was running, who is communicating with me also, who is taking the request from me. Okay, this was your master node. Last time I created one container. In that container, my Jenkins server is running. That server is your master node. Now I am configuring a worker node. Okay, and in this worker node, my all the jobs will be executed. So I will not execute the jobs within my master node. I will execute the jobs in this particular worker node. Okay, again, let me do this setup. Then you will see how it will work. So guys, have some patience. Once this end-to-end project you will see, then you will understand the entire flow. Why are we doing it? Okay, this is the flow you will see everywhere used in the companies. Okay, same flow will be used. Let me again log into my root user over here. Okay. Now, what I'm saying, last time when I was executing my Jenkins job, this is my Jenkins job which I was executing. In the top, they will also show you where exactly my job was running. So they are saying it is running on your Jenkins. Jenkins means your master node itself. So this particular job was getting executed in my master node itself. Okay. We are creating worker node because we wanted to distribute the load. Okay, right now I have one master node. If all the pipelines, all the jobs you are going to execute in that master node itself, so this master node will be over occupied. Okay, because in your company you will have hundreds of pipeline. Like you won't believe when you will work as a DevOps engineer, what you will see at a time, hundreds of pipeline will be running. Running all this pipeline in one system will have an overloaded system. That's why we are distributing that load. We are saying that I am going to make request to my master node. My master node is going to distribute the load to multiple agents, multiple worker nodes. Some of the jobs will be running here, some of the jobs will be running here, some of the jobs will be running over here. So my load will be distributed to my worker nodes. That's why I'm creating my worker node over here. I can show you in a single node cluster as well, but in real world, you will see multi-node cluster everywhere. That's why here also I'm going to configure a multi-node cluster. How to configure? This is a separate EC2 instance. This one I wanted to configure as worker node of my Jenkins server. Right now, my Jenkins server is running. Let me exit from here. Right now, my Jenkins server is running inside a container, but your Jenkins server may be running in your virtual machine directly as well. But I have launched it inside a container to make the setup very simple. So my Jenkins master node is this one, your container where your Jenkins server is running. And then this entire EC2 instance, I'm going to configure as worker node. That's the setup we will do. Okay. So if you wanted to configure a worker node, in that case, you will have to again go to Jenkins. Let me open the Jenkins dashboard in a new tab. Okay. Here you can go to manage Jenkins. Okay. When you go to manage Jenkins, you will see we have an option of nodes over here. Here you will be able to see how many worker nodes are currently being attached to your Jenkins. And right now you can see in the node section, they are showing you only one node, and that is called as built-in node. Built-in node means this is your master node itself. So I have only my master node right now. In this master node, entire my Jenkins master programs are also running, as well as if you will execute any of the pipeline, those pipeline job will also get executed in the same node. So I have only one system over here. That is called a single node cluster I have. I have only one node which is working like master and slave both. But I wanted to create one new node right now. So I can click on this button to create a new node. Then they are saying you want to create a new node. What will be the name? You can give any name. Let's say I will give name EC2. And then I am going to configure this particular system as my one of the agent, one of the worker node. So I will configure it as one of the permanent agents. So my Jenkins will keep on connecting with this worker node and will keep on scheduling the job as required. Okay. So the first thing what Jenkins is asking me that now you want me to execute my job in a different system, in a different worker node. So in that worker node, there could be multiple files and directories which it may be following. So whatever data I will be creating, in which directory I should store that data. Okay. So what I will say that you can store all those data. They're saying what is your remote root directory? Where should I store all the data? So you will see right now I'm giving a folder. Let's say let me create a directory over here. I'm creating a directory. Let's say data directory over here. You can give anything. And what I'm saying, Jenkins, I am going to configure this system as your worker node. So whatever process or programs you will be running and whatever data will be originated from there, you can keep on storing those data in this particular directory of my worker node. Okay, so same information you have to give the master node. So master node will acknowledge that, okay, when you will configure this worker node, in this worker node, at this particular directory, I will store all of the data, whichever will be required. Okay, then what are the labels? Okay, so labels means if you will have multiple worker node in future, so you can give a unique label to this worker node so that you can select them. Okay, so here, let's say I will give a label EC2. Why this label we are giving? Again, it will come in a minute. You will see it. Okay, and let me save this. So you can see now I had earlier one system. Now I had one more system which is being shown me over here, but currently the system is shown as disconnected. It's not connected right now. Why? Because if you wanted to connect a worker node with your Jenkins master node, then that particular worker node must have an agent program running. Jenkins agent program must be running. That agent program will be taking the communication between your master system and your worker system. And that's why you can say Jenkins is giving me two commands over here. Jenkins is saying that can you please copy these two commands? This is the first command. Can you please copy this? Can you please go to your worker node and can you please paste this command? What this command will do? It will download the agent program in your worker node. Okay. And if you remember in Java, if whenever you have any application in Java, that will be in jar format. So here Jenkins have downloaded my agent program. My agent program is downloaded over here. But my agent program is not running yet. If you want to run your agent program, you have to run this command, copy this command. What this command will do? This command will start the agent program in your worker node. And once this agent program will be started in my worker node, it will automatically connect with my master node and it will start listening for the request from the master node. Master node says you have to run a job. My worker node will take that particular request and master worker node is going to execute it. Okay. So I have first downloaded my agent program, Jenkins agent program. And when I'm trying to run that agent program, I'm getting an error over here. They are saying Java not installed. Why? Because Jenkins is built on Java. This agent is also built on Java. So if you want to start a program, you must have Java installed in your system. So you will have to do a small setup, go back to the internet and just search Java JDK install. You have to install Java development kit to make your this particular worker node work over here. So I'm going to download a RPM package. Why RPM package? Because right now I'm in a Red Hat Linux. Okay, in Red Hat Linux, only RPM package will work. So I'll copy this particular command or this particular file. Okay, this file will have my Java JDK installation path, you can say. Okay, a location, you can say. So I will take this thing. And in Linux system, guys, if you want to download a file, okay, so you can use curl command or you can use wget command as well. Wget command will help you to download a file from the internet in your Linux system. So I'm saying that I have one RPM file, okay, for my Java program for Java JDK. Can you please download this? Okay. Why I'm doing it? Because if I don't do it, if I try to install Java directly with the yum over here, if I say yum, can you please install Java for me? Okay, so I'm saying yum, can you install Java for me? So yum will check, do they have anything for Java or Java JDK? Okay, they are trying to find out and they are saying, yes, I found something Java 24 version over here. Okay, Amazon Currento version. Let me install this one. Okay, let's see how it's going to work. Okay. If it don't work, then I'm going to install a JDK from the link I was doing. So I'm trying to install Java in my system, okay, via yum command. But yum command has a limited amount of knowledge about the packages. Some of the packages, it may happen that your yum is not aware about. So in that case, you will have to install and those packages via manually downloading it and extracting it. Same concept work in Windows as well. In Windows, you can see we have Microsoft Store. Now in Microsoft Store, you don't have all the packages, all kind of program. Okay, so if you have a program which is not in Microsoft Store, how will you install in the Windows system? You will go to internet, download the exe file of that program, double click, and you will install it, right? So similar thing we can also do. Okay, and you can see for us it worked. Okay, whatever I have installed, you can see it worked. As I run this command, my Java is installed, so I don't need to follow this particular command. It's not required now. With yum only, I have installed Java, and you can see now my agent program is started, and it is saying connected. Connected means my agent program or my agent is now connected with my master node. Okay, so my master node was here, and if I refresh my page, so they will say that agent is connected. Okay, now agent is connected means I have Jenkins multi-node cluster. This is my Jenkins master node, and this is my Jenkins worker node. Okay, and now this will fix all of our problems. Okay, so we were having a problem, right? Our pipeline was getting failed. Why? Because this pipeline was getting executed in my master node itself, and in my master node I didn't had yum. But now I have configured a worker node, and this worker node has a yum pre-installed. So now I will try running my pipeline on this particular system, and it should work because here yum is already present. Let me connect. Let me have a duplicate connection to this particular system, this particular worker node. So in my worker node, I have yum installed. The only thing I have to ask my Jenkins is that Jenkins, you have to execute this job on this particular worker node which I have configured. Why? Because this particular worker node have yum already installed, so I will be able to run my pipeline. Okay, this particular worker node have all the settings, all the data which is required for my pipeline to be executed. So I will go back here, go back to my pipeline. So in the pipeline configuration, in the top, you will see we have one option. Okay, and this option is where exactly you want to execute this pipeline. Right now, we are mentioning I wanted to execute this pipeline in any of my system, any of the worker node. If you have 4 worker node, Jenkins will randomly schedule this particular pipeline in any one of them. Okay, but let's say I want this particular pipeline to be scheduled on a particular worker node, on a particular agent. So you can remove this, and now you can define one label over here. Okay, as a Jenkins, you have to execute this particular pipeline on a particular worker node. In this case, we have already configured one worker node. You can see this is a worker node which we have configured with a name EC2. And while doing this configuration of this worker node, we have given this worker node a label as well. EC2 is one of the label we have given. So this label is now going to help us. I'll say Jenkins, I have configured one worker node whose label is EC2. And can you please execute this command in that particular worker node which has a label EC2? So now this particular pipeline will not be executed in your Java, in your Jenkins master node. This will be executed in a worker node over here, which is separately being configured by us. I will save this, and now I will click on the build now. So whenever you click on the build now means your pipeline will be executed. You can see your pipeline is being executed for the 3rd time now. Okay, if you just check the console output to identify what exactly is going on, now you will see a difference that now it is running on your EC2 system, not in your Jenkins system, your master node. Okay, but still my pipeline got failed. They're saying this time they got failed by cloning my repository. Okay, and one of the reason for this fail is because whenever they try to perform my steps which I have defined in the pipeline, if you go back to those steps, okay, the first step which I have defined in my pipeline is to download my source code. And to download the source code, behind the scene, they will need Git software. And Git program is not right now installed in your worker node. So in your worker node, you don't have Git installed. That's why it is failing. So let me install Git in my worker node so it will not fail next time. Okay. So Git is a basic requirement which your worker node must have. Okay. Now your worker node will have Git. If I again trigger the same pipeline without making any changes, okay, I will again click on the build now button. So now you will see, okay, the fourth time it is getting triggered. If I click over here, go to my console output. So now they will again try to do it on my, you can see EC2 system. This is a label which I have given while configuring my worker node. You can see this is a label I have given while configuring my worker node in this node section. Okay. And you can see this time it got successful. Because in my worker node, I had my YAML already present. That's why you can see when they did this command got successful. You can see they are trying to install uh, Python for me. And they are saying Python is already installed in the system, but they are not installing it once again. Then they are trying to install pip for me. You can see the pip is getting installed. Once the pip is installed, then they are trying to execute this command, which is executing or which is installing all my Python requirements. And you can see it is getting installed right now. Once this is completed, now they're trying to execute PyTest command and they are running my test cases. And because my test cases was successful, that's why it worked over here. Okay, so now I don't have to perform these steps manually every time. I've created a pipeline. Whenever my repository will have a new change, I can just trigger this pipeline and everything will be done. Okay, and when I was configuring my worker node, you remember I created one folder over here /data, and I said that here in this /data folder you can put cd data. In the /data folder, Jenkins, you can put all your files if you have anything. So if I do ls command, you can see here some folders are created. If you go to workspace folder, and if you again to ls, then you can see your pipeline information is there. If I go to this particular name over here, if I do ls, you can see my entire repository is being cloned over here. These are the code of my repository which got downloaded in my worker node. So the flow is very simple. I asked Jenkins, I triggered Jenkins pipeline. I asked Jenkins, can you please execute it for us? So Jenkins accepted my request. Then behind the scene, Jenkins forwarded that request to one of the worker node. Right now, I have only one worker node, but you can have multiple worker node as well. The Jenkins have forwarded that request, okay, to this worker node. And how are your Jenkins master and Jenkins worker is communicating? Because they are two different systems. They are communicating via agent. So in my worker node, I am running an agent program. This agent program is keep on listening from the master node, and whatever master node will ask, this agent program is going to execute it, and then agent program is going to give you the response as well. So you are a DevOps engineer. You have to manage everything from this kind of UI, from this web console. From here, you can see the output as well. Now these output are coming from your worker node. So you don't have to go to your worker node manually and check what kind of output it is returning you. Everything you can do it from the master node. The master node is giving you one interface, but behind the scene, master node is using these worker nodes for executing your jobs because these jobs will need some computing power. Okay. So that's what we have done. This is the first step which let's say is done over here. Now let's say I wanted to go back to my pipeline. I wanted to add some more steps over here. Okay. So let's say I have executed my test cases. My test cases are working fine. After executing my test cases, let's say I wanted to run one more stage. Okay. And this stage is about running the Flake 8 test cases. So in Python, guys, we have some Python coding standard which developers must have to follow. So Flake 8 will help us to identify whether my code is written properly as per the standard or not. If it is not, they will highlight it. They will highlight it as an issue over here. Okay. So now here the command which can run my Flake 8 test. If you want, you can do it or you can skip it as well. I can say Python 3, I have a module, Flake 8. Can you please execute it for me? So one more step now I have added in my pipeline. So my pipeline is getting bigger and bigger. We are keep on adding more and more steps. I will again click on the build now. And what you will see, the fifth time my pipeline has been triggered. Okay, so if I go back, click over here, okay, and if you click on pipeline steps, it will show you all the steps of the pipeline. Or these are the steps which behind the scene happen. Everything looks to be successful as of now. Okay, if you check the console output, they will show you everything. That this time all the things were already present, but you have added one more step, Python 3 flake it, and this that is also have also given you green signal. Okay, then if you click on pipeline overview, they will show you that these are the steps which you have in your pipeline. So from the starting, what we will do, we'll first download the source code. Then we will install the Python. Then we'll install the pip. We will install your Python dependencies. We will execute the test cases. We will run the flake test. So you can see this is now look like a pipeline, right? And this pipeline has so many jobs between it. These are individual jobs which we are executing over here. Each job is made for a specific task. Okay. Now what I can do, I can automate it as well. Right now I'm triggering this pipeline manually. Okay, but I can automate it as well. For that, we have some options of triggers available. Okay, so if I go to configure section, I can say, Jenkins, can you do one thing? Right now, I'm triggering this particular pipeline every time manually. Let's say my developer went to my repository and my developer have made some new changes. Let's say my developer went here and updated the app.py file. Okay, so let me update this manually for now. So let's say my developer is updating the file. Now he is printing over here something, let's say buy. So my developer have updated the code, and this code is being updated in your repository. And as we discussed, whenever your code will be updated, you have to again trigger your pipeline. Okay, and your pipeline must again test all the cases, all the scenarios. So as I made some changes, if I go back to my Jenkins and I say, Jenkins, can you please trigger it one more time? What Jenkins will do, Jenkins will automatically download the latest code, and then Jenkins will again perform the same steps which we did one more time over here. And you can see with the latest code, it got failed. With the older code, it was working fine, but with the latest code, it got failed. And you can click over here and you can go to pipeline overview and you can see which step got failed. This step got failed where they were trying to execute test cases. And what is the exact error? So they are saying that you have a test case failure. I was expecting hooray as a keyword in the response, but you have given the pie. This is again because of test cases mismatch. We have discussed about this test case as well in our last class. Okay, so here I am giving some other keyword, but in my test case they were expecting something else. That's why it got failed. So if you want to fix it, so what you can do, you can either update your test case as well. Let me update my test case as well, so they will not fail it. I will update it. I will again commit this. So I have a new change in my repository. I again want my developer have again made the changes to fix my pipeline. So I will again go back and I will again trigger it, and this will be triggered seventh time this time. So you can see again as I triggered seventh time it is going to be done. But right now I'm triggering this pipeline manually. But if you wanted to automate it, you can see it got work this time. If you want to make it automate, then we can also integrate GitHub with Jenkins. Okay. So right now my Jenkins don't know. Jenkins is a different tool. Okay. Your GitHub is a different tool. So your developer is updating the code directly on the GitHub platform. Jenkins is running somewhere else. How Jenkins will be aware when GitHub have a new changes or new code? So for that, we have to add some trigger, and we will add that trigger over GitHub. We say GitHub, whenever you will have a new new code, whenever there is a new code is being pushed to your repository, can you please trigger my pipeline, which is running somewhere else? Okay, trigger my pipeline. GitHub have this support, and we can utilize it. So I will go back. I will copy my Jenkins server URL. So my Jenkins server is running in this particular location. Okay, so you have to give this location or this URL to your GitHub. So GitHub knows where exactly your Jenkins is running. So I will copy this. I will go back to GitHub, and then you can go back to your repository settings. Okay. Okay. And then you can go back to your webhooks, and the webhooks, you can see webhooks allows your external services to be notified when certain event happen in GitHub. So in my case, I want whenever there will be a push event happen in GitHub, I want my Jenkins to be notified. So let me give my password over here. They are just confirming before letting me add it. So they are saying which is the URL, where exactly your Jenkins is running. So I'm saying Jenkins is running at this IP address and this particular port number. And then here you have to add an endpoint, the name GitHub web hook. and then slash. That's it. This is the endpoint which you have to add, payload URL you have to add. And then I will say GitHub, whenever there will be a push event, whenever someone will push some code to your GitHub repository, can you please automatically trigger my Jenkins pipeline? Okay. As you do this, click on the add webhook. Your GitHub will get integrated with your Jenkins. And you can see now they have a connection. You can see tick means my GitHub is now connected with my Jenkins. So if I go back to my Jenkins, you can see my Jenkins is built only 7 times I have built my job. I'm not going to click it manually. I will go back to my repository. I'm a developer. Let's say I have made some new changes in the code. So I'm a developer. I will go to my file. Let's say I just update some data over here. I'm just creating one sam x equal to 1, 2, 3, 4. I'm just creating a one extra line. Means one extra code I have added, one extra algorithm I have added. As I will do the commit, as I will commit it, what ideally you want that whenever my developer will make change, automatically that changes should be tested. So if you refresh, okay, so let's see whether my Jenkins is going to be triggered or not. So I have made my changes in my main branch, okay, and ideally as you made the changes, my Jenkins should get notified about it. But Jenkins didn't got notified. Why? Because in Jenkins also you have to add a small settings. You have to go to configure section. Okay. And here in the trigger section, you have to select GitHub hook trigger. It means you are saying to Jenkins pipeline, the Jenkins pipeline, whenever GitHub will trigger you, you have to accept that request and you have to execute the job. Save this. And now onward, what happened? Whenever your developer will make any new changes, automatically your pipeline will be triggered. Everything is automated now. And that is the reason why we are using Jenkins. So now you don't have to run your test cases and everything manually one by one. Jenkins will automatically execute it every time for you. Okay. So if I come back, this time if I go to my any of the file, let's say I'm going to app.py file, and let's say if I make a new change over here, let's say some 5, 6, some extra data I'm just adding to make a push event. As I will do the push event, I will go back to my Jenkins. Okay, as a Jenkins, are you being notified that I have a new changes? So, okay, so you can refresh. So Jenkins, till now we have executed 7 times. Okay, so you can see automatically Jenkins have executed 8 times. Okay, and this has been triggered remotely. Remotely from my remote system, from my GitHub, my Jenkins was triggered. So now this can be automated. As your developer will make the changes, automatically your test cases and everything will be executed. Although it got failed, we have to check the issue. You can click over here, go to your pipeline overview once again and check which job failed. So they are saying this flake 8 test cases have been failed. Why it got failed? You can see this is a thing they are telling me. They are saying you have created one variable X, but you are not using this variable. So as such, this is not a very big issue. Okay, you may create a variable, you may not use it, it's not causing a problem, but it's not good for quality of your application. It's not good for readability of your application. So Flakegate is highlighting that you are creating a variable, but you are not using it. So ideally, your developer should fix it. So now you will ask your developer, my pipeline has failed. Automatically, your developer will keep on monitoring your pipeline. Your developer will get to know that, okay, this is the issue. The developer will go back to his application, and let's say he will fix this code. He will remove that line. And now as my developer will fix the code, because my developer is going to update the code hundreds of times in a day. Okay. So automatically my Jenkins will, you can see 9th time my Jenkins has been triggered. Build has been triggered. Okay. So we have automated the entire flow over here with the help of Jenkins. So guys, now is it getting clear why are we using Jenkins? Or it is still not clear? So Isha, yes, you can use code pipeline. AWS code pipeline is very similar to Jenkins. They are the competitors of each other. You can use GitLab, you can use GitHub Actions, you can use Azure DevOps. All these tools can be used behind the scene. Most of them, all of them are doing the same job. Okay. So if you wanted to give more power to your worker node, Shubham, so while launching your worker node, whenever you launch your worker node, select an instance type of a bigger value. Okay. So whenever you try to click on launch instance button, okay, here you have an option. If you wanted to give more power, select a bigger instance type. Okay, so you can see I can select, I will say that I want more power, I want more RAM and more CPU on my worker node. So I'm going to configure my another worker node. I will give 8 core CPU, 32 GB of RAM. You can select it. It's totally on your virtual machine. Okay, the time which Jenkins is showing over here, Prashant, is in UTC, I think, or some other time. It's not in IST. Okay, so you can go to your Jenkins server. By default, in your Linux, IST time is not there. So it may be UK time or some other time. That's why it is there. We can change it also. It's not a big deal. Okay. No, Docker and Kubernetes are not a CI/CD pipeline tool, right? Their job is different. Okay. Jenkins' job is to streamline everything, okay, and make or execute everything one by one in a order which will make sense. Docker and Kubernetes have a different job. Okay, Docker you already know. I will show you how Docker will work now. Okay. The next thing after this is I will go back to my configure and now I'm going to add some more steps in my pipeline. Okay. And the next step which I'm going to add in a pipeline is, let's say all my test cases are passed. Now I will, my one part of my pipeline is completed. My continuous integration is completed. Now I will do the deployment. So I will add one more step over here. And this will be the step where I'm going to build my Docker image. Build Docker image. Okay. And then I will say steps. Because once your application has been tested and everything is good, now your application is ready for the deployment. And if you want to deploy your application, what we discussed, that we will not deploy our application manually. We will create one image file, Docker image. That image will have all the things which is required for your application to run. So we'll first build this image. And once this image is being built, from this image, we are going to launch a container. And that container will have our application running. So in this case, in our repository, my developer have already created one Docker file. We are going to use this Docker file to build the image. And for that, we have Docker build command, right? So here I'm going to write one more step. Okay, so steps spelling is wrong. Steps. Okay. The first step would be, I'll say, can you please, okay, can you please install Docker in my worker node? My worker node must have a Docker. Then I will say, can you please start my Docker engine? Okay. And then the third thing is, I will say that let's do a Docker build command. And then while building the image, you have to give exact tag of the image, what name you want to give to your image. I'll say GFG workshop. Okay. And then version will be V1, for example, or let's say you will go with latest version. And where exactly is your Docker file? I will say in my repository base location, my Docker file is present. I will say dot. So what this is going to do, this is going to build a Docker image for you. And this Docker image will be built in your worker node, because in worker node, all these jobs are getting executed. So in my worker node, my Docker image will get built. And once your image is built, the next job will be, or the final job will be, this is called as your deployment part. Okay. And let's say right now we are not deploying to dev production environment. Let's say we are deploying to dev environment for further testing. So we can say dev deployment. Okay. And once, let me say steps, and then I will say, what is the steps? How we deploy our application? We have Docker run command. I say Docker, I wanted to run a particular container over here. Okay, Docker run command. And while running this particular container, I will give a name. Let's say name will be anything, WebOS. Okay, and then I will give the image name which I have just built in the above step. I will copy this image name. I will give this image name or paste this image name over here. Then my container will be launched. And then you can imagine your server is right now running. Okay. So while running this, your container will be created. But if you want your container to be accessed from the outside world, you have to do a port mapping as well. We discussed about port mapping, right? So I will say anyone who will come to my base system at port number 81, they will be mapped to my server, and my server will be running on port number 500. Okay. So if you do till here, and if you save this, okay, and now if you run this, right now I have made some changes in my Docker files. I'm clicking in right now manually, but we will do it automatically from the next time. I see it got failed. Why it got failed? Let's check the error first. Why it got failed? Okay. So they are saying there is some syntax issue in my pipeline script. Let me just fix that syntax issue first. I will go back to my configuration over here. So what is the issue? So we have defined different kind of stages. Here also we have our stages. Okay, I forget to add a curly braces over here. Okay, so this curly braces starts over here. I have to close a curly braces as well. And I think this should be fine. Let me save this and let me build it once again. So now this is running for the 11th time. And if I again check for the 11th time, what exactly is happening? So now you can see what they are doing. They are first of all installing Docker in my worker node because everything is getting executed on your worker node. Docker is getting installed. Once Docker will be installed, the next step will be to configure or to start your Docker engine. Okay, so you can check it from the pipeline overview section as well. Now you can see in your pipeline, we have so many steps. And they're highlighting that these many steps are completed. This is the step right now, which is running state. And they will show you the logs as well. They are trying to build my Docker image. Okay, you can see they are trying to build my Docker image. And whenever they try to build a Docker image, this is a logs which get printed. So they are trying to, in my Docker image, they will have everything which is required for my application to run. So once this Docker image will be built, okay, they will run my application. And my application will be running on port number 81. So let me go back to the worker node security group as well. And in the security group, let me allow that particular, what we say, port number. Otherwise, security group will block it. So I'm going to the security group of my worker node right now. Okay. And let me allow that port number so we will be able to use it. Okay. So let's see, let it load. Okay. So it's still loading right now. Okay. Let me select this. Let me go to security section and let me go to my security group. Okay. Okay, this is my security group. So for every virtual machine or EC2 instance you create, by default, they are creating a new security group. So here also the security group or the firewall, which is attached to my worker node. Okay, here I will have to edit the inbound rule and I will have to, let's say I will allow all the traffic for now to make it very simple, all traffic, save rules. So you can see, let's see our build is completed or not. You can see deployment is still happening. There's a problem which happened. You can see I use this docker run hyphen name hyphen name webOS. It has started my Flask server. You can see Flask server is running, but my pipeline is not completed. Why? Because I forget to run it in detached mode. So if you forget to run your server on a detached mode, it will keep on eating the terminal or the space of your current shell. So right now you can see it is keep on printing with the logs. I forget to attach. That's why. So next time what we will do, we'll run it in detached mode. So it will run it the container in the background. Okay. So if I go to my worker node and check what is happening in my worker node, okay. So if I do Docker PS, you can see in my worker node there will be one container running. And if I copy this IP address, okay, and then if I check what is happening at port number 81, sorry, I printed 2 times 81. Okay. So your server should be available over here. Okay. Again, I think they may be trying with HTTPS, but we have HTTP only. We are trying to hit to over here. It's not working. Let me check one more thing. Let me go back to my EC2 instance. 81 is mapped with port number 500 right now. And this is my public IP address. If I go back to security, I hope I have updated the security group correctly. All the traffic, security group. Okay. And let me do one more thing. Okay, I think it is running on port number 80 right now, not in port number 500. That's why it is not working. I have done a wrong port mapping. Let me go back and check what exactly happened. So guys, I think in my local system, when I was showing you this practical, I added here the port number 500. But in my GitHub, I still have the port number 80 over here. So my server will be running on port number 80, not on 500. That's why it is not working. Let me do one thing because this particular pipeline is currently being stuck. I started in the foreground. Let me cancel this pipeline. Okay. And let me do one more thing. Let me cancel this. I will go to my configure section. I will define two things over here. The first thing is that my pipeline is running on port number 80, not in port number 500. And the second thing is, please run this particular container in detached mode, -d I will use. I will save this. So right now you can see I have 11th build till now. But as I will go to my repository, let me update my Docker file as well. In my Docker file, I think I have mentioned 500 that is causing the problem. Let me make a change in my Docker file and make it 80. And as I will make these changes, commit these changes, okay, what will happen? A new commit will happen on my GitHub. Automatically, you can see 12th time it got triggered. Okay. And then it will again try to build my Docker image. Now this time it will build a new Docker image. Why? Because my application code has been changed. So whenever your application code will be changed, a new Docker image will be built. And then this time they will launch the container for us. In that container, our entire application will be running, which we will be accessing further. So you can see they are currently trying to build my Docker image, and then they will do the deployment. Okay. So Git link I have already shared, Pravana, with all of you. I will again share up in the end of this class. And this deployment got failed. One of the reasons why deployment got failed, guys, because last time I started one container with the same name, WebOS, and this time I'm again trying to create a container with the same name. So you can't have two containers running in one Docker engine with the same name. Okay. So last time what happened, although I did a wrong port mapping, but one container was started with the name WebOS. You can see if I do ps-a, this container have been closed, but the container is still available over here with the name WebOS. Okay. So you can't have two containers with the same name because again, it is trying to create a container with the same similar name WebOS. So in this case, you have to terminate this container, remove this container. If you want to remove a container, we have a command docker rm command I'm going to use, docker rm -f, and then I will say f means forcefully, and then I will give my WebOS. Okay. So guys, I'm audible, I hope. Looks like it is a little slow, this EC2 instance. You guys can hear me or not? You guys can hear me now? I'm audible once again. I think there was a small network drop. You can hear me? Let me refresh my screen because this terminal was stuck. Okay. So Sarad, see, master node which I am running over here, okay, that is my Jenkins image I am using, Docker image I am using for Jenkins, for creating my Jenkins master node, right? That's what I'm doing. The Jenkins, I hope guys you can hear me. Looks like there is some network issue at my end. I have changed my network and let me stop my camera as well. Let me know if I'm audible now. So yes. So yeah, I was telling to you, know how Docker containers are. So go inside your Docker container of Jenkins and you go there. You can see that yum command will not be present over here. You can check that by yourself. Okay. Because the image which I was using for Jenkins, that image don't have yum installed, you can say. They are not using Red Hat or CentOS or Fedora as one of the base image. That's why yum was not present. So I have set up the entire new worker node where I'm running my application. So, okay, what happened to this EC2 instance? Guys, I hope I'm audible. Still audible, right? My EC2 instance is taking some time. So I was explaining you about the RM command. Okay. Yes, Yum is the package manager. So you tell me, Ayush, like pip is a package manager for Python, right? So will pip work for a Java application? It will not work. Java has their own package manager. Node has their own package manager. Pip is just for Python. Similarly, Yum is a package manager for Red Hat Linux operating system. Okay, Ubuntu is a different Linux operating system, so they don't support Yum. They have their own package manager, that is apt. Okay, so it will change as per the operating system you are using. Okay, because in this training I am mainly showing you about Red Hat Linux. That's why you will see Yum over there. But if you work with Ubuntu or some other operating system, they have different package manager. So why we haven't selected anything, Asarath. We are using one of the official image of Jenkins. So they are using behind the scene. If you this particular image which we are using, they might be using Ubuntu behind the scene. Okay, we are running this particular container inside a EC2 instance. I think you're getting confused with the virtual machine and containerization concept. So, okay, so this I am running as a container, right? Why can't use its default package? You can use default package manager, Ronak. In that case, you will have to update your entire pipeline script which I have created. This pipeline script you have to update, and everywhere you have to use apt. You can do that. But again, not all of you are aware about Ubuntu, right? So because in this particular session, I have given you some explanation about Red Hat. That's why you are at least aware Yum is something present in Red Hat for a package management. You're using it. Okay. So if you are still not clear what is the main purpose of using Jenkins, then I will say that something is wrong at your end. Okay, because we have discussed it, we have seen the entire pipeline. We took almost 2 hours to discuss the same thing, and if it's still not clear, then I will highly recommend to watch the older sessions. Okay. So guys, looks like my servers are again back. So I just have to do one small step over here. And what I will say that whenever you are trying to create a new container for me, please remove the older one. So here I have to add one step, docker rm command -f, and then I will give the container name. What this will do, this will remove your container, and then this will launch a new container, because we can't have two containers running with the same image. That was the issue we were facing. As I will do it, I will save this. Okay. We can then run it once again. Okay. Now I will click build now once again from our end. Okay. So let's see this time whether it's going to deploy our container or not. Okay. So I will go back and check for this build number 13, what exactly is happening. So if we check the pipeline overview, so it's taking some time. So here I can see that it got succeeded. If it got succeeded, it means now my container will be running. My server will be running. Okay. So if I go back over here and if I again hit it once again, if I hit it, so what you will see that whatever I have defined in my application is now available. Why is the one of the message which I printed is now available over here. Okay. And now everything is being automated, guys. So you don't have to do anything manually. As your developer will go back to the source code, and as your developer will make some new changes. Okay. So it will be automatically applied. Those changes will be automatically applied, and we can see them. We can see the response of them. Okay. So here, let's say I had two endpoint. One was a slash endpoint, and the other one was slash test endpoint. So let me go back here. Let me make a small change over here. Let me say I wanted to again say hi GFG workshop. So I made the changes. Okay, let me copy these changes. As I will save this, automatically my Jenkins pipeline will trigger. Jenkins pipeline will check whether all the changes are proper or not, whether all the test cases are working fine or not. If everything will work fine, then only it will be deployed. Otherwise, it will not be deployed. Okay, so you can see my user is still seeing the older data, although my developer have made some new changes. Okay, but it will not be available to your user once it is properly being tested. Okay. So guys, let me just do one thing. Let me change my network once again. Okay. I hope I am audible once again. There was small glitch. Okay. So I hope all of you can hear me. Let me try counting my changes. Yes. So you can see I have made a small change in my code. My developer has made a small change. What will happen? These changes will be first tested by your Jenkins. So if we go back to Jenkins and check Jenkins, I have made one more change. You can see automatically my 14th build was start. And if I see what is happening at my 14th build, okay, you can see it got failed. And because it got failed, you can see it was never deployed. The container was never deployed. And why it was failed? Because I have made change in my app.py file. I have added a data hi GFG workshop, but they were expecting buy, and that's why it got failed. So whenever your test case will fail or anything will fail, your changes will never be deployed to production system. You can see my user can still see the older data because my newer data may have some bug. Okay, my newer data may have some bug. So in that case, my test cases have identified that bug. So because it has bug, it was not deployed. But as my developer will fix it, let me go back to my test case and let me change my test case as well. So my test case was expecting buy as one of the keyword, but I will update it. Now test will expect the same keyword. So this time my test case will work fine. Okay. And because it will work fine this time, you can see again one more build will start automatically. 15th one is start. And after some time, you can keep on reloading your application. You will start be able to see the newer data. Once it will be deployed, let's see what is the status. So it will again do the entire testing. It will again do all the steps, and then it will be available in front of us. Okay. So you can see it is executed. Let me just go back over here and check the pipeline steps. Okay, so pipeline steps is just giving me a small overview. But if I go to pipeline overview, you can see they are doing the deployment right now. And deployment is completed. It means now if I go back, my user will just refresh. Okay, you can see he is able to see the newer data. So without doing any manual approach, we have created one pipeline, and this pipeline is now doing everything end to end for us. Okay, so guys, Jenkins is a very big topic. A lot of things I can cover for Jenkins, but we don't have much time left. We have to start with our Kubernetes practical as well. So let's start with Kubernetes now. I hope at least you got an idea. So in this workshop, our main idea is that you are aware about Jenkins, you are aware about Docker, you are aware about cloud computing, you are aware about GitHub. Okay, you are aware about these integrations. These tools are very big. Okay, I usually take almost 80 to 90 hours of training for entire DevOps tools. Okay. So we can't learn everything. We have very limited time, but we will learn. At least you will have an idea what all these things are, so that in future, if you again get to know, you will hear somewhere Jenkins name is written. So at least you will have an idea, okay, what Jenkins exactly does. Okay. So can you tell us to why we need to build a Docker image in Jenkins step? Okay, then you tell me, Sarad, if I don't build a Docker image, how will you run your application? Okay. So for running this Python application, what I did till here, so if I take a screenshot, how will you run your application? You will go back and you will run your Python app.py command manually, right? So do you think whenever your developer will make any changes, your developer will call you that, Sarad, can you please go to your virtual machine? Can you please run that Python app.py command? Sir, I have updated some new things in my dependencies. Can you please go back to virtual machine? Can you please install those packages once again? You can't do it, right? And in real world, the changes will be done more frequently. So we are building Docker image because Docker image, once your Docker image is built, Docker image has the entire your application requirement. Whatever is required for your application to work, everything Docker image has. Once Docker image is created, now from this Docker image, you can create millions of containers. So again, anyway, we are going to discuss about Kubernetes. So this part will be helpful for you to understand about Kubernetes. Okay. So what I did, you just tell me that let's say you have a virtual machine. Okay. And then you have an application which is in Python or Java or whatever programming language you love. Now you want to deploy this application. If you do it manually, you manually install all the dependencies, manually install all the configuration, manually copy your code, and manually start your server. You can do it one time. And you can do it if your user base is very small, only few people are using your services. But you tell me that let's say your server was used by only one person right now, few persons right now, but suddenly your website got viral and you are getting more load. So what will you do in that situation? In that situation, you will have to launch one more virtual machine. In the system, you will have to again install all these dependencies one by one. Again, do the entire your server configuration. Right now we are launching a very small basic server, Python server, but you will have to do so many things. So do you think you will be able to manually configure all these things in a second? You can't do it. It will take 10 minutes, 15 minutes, 30 minutes. There will be a downtime attached over here. So whenever someone do upgrade, even IRCTC also, you will see IRCTC is usually down from 11 p.m. to 12 a.m. Why? Because they do some upgrade behind the scene. But this is not good. If your server is down for an hour, you are losing your business, right? Okay. So you are doing everything, or you are even scaling your application manually. Means manually you are again doing the entire setup of your server. It will take some time for you to create it. It's not possible. So what we are doing, we are creating one Docker image. Okay. And this Docker image, every time this Docker image has your entire source code as well as everything which is required for your code to work. This has your source code inserted into it. And once this image is created, from this image, you can create your running application in less than a second. You can do it. And the best part is, whenever your developer will update the code, he has made some new changes in the code. So obviously, you will have to ask Jenkins to update your Docker image as well. So that Docker image has a newer code, newer application. Okay, newer application files. And once you have this particular Docker image is ready, so now what benefit you will have? So now let's say you have more load, so you can launch more and more and more and more containers. And each containers are running your same server. They are each replica, exact same copy of each other. So now we can use some load balancer and we can distribute the traffic between them. Now the load balancer will come up in the picture. Okay. Are you getting it? So we have to launch more and more replica of our server. How can you create a replica of your server if you don't have a template created? So Docker image is just a template. And we are asking our Jenkins to create this template to run Docker build command so that my template will be ready. And from this template, I will create my container. If I have to launch more replica, more load I have to launch more copy of the server so that load can be distributed into it. So what you see in Netflix, whenever you watch Netflix, Netflix is not running a single virtual machine. Netflix is behind the scene running multiple virtual machines, 30, 40 virtual machines they may be running. And in each of the virtual machines, they may have the same application deployed, replica deployed. They distribute, okay, they distribute a load between it. Okay. Creating a virtual machine takes time, but creating a container is very fast, less than a second. So that's why we have to create this application image, app image, or your Docker image, so that our application will be ready for the deployment. And that's where Docker comes up in the picture. Is it clear, guys? Why are we using it? Yes, we will create new Docker container. Okay. So whenever you get load, you will launch more and more Docker container. Yes, virtual machine will also be required. So usually what happens in your servers, you have multiple virtual machines created. In these virtual machines, in top of these virtual machines, we create our containers. So let's say this virtual machine was in idle mode, but as I got more load, I will go to this virtual machine and launch my 5 containers. So that load can be distributed into these containers. Okay. And one of the reasons why are we using containers, why we are not doing entire setup on the virtual machine, because you may have heard about an architecture called as Microservices Architecture. Okay. So whenever you have an application, okay, you have a bigger application. Whenever I say bigger application means you have one application who is offering multiple kind of features, multiple kind of services. In this case, you can take any of the example. Nowadays, everyone is almost following the microservices architecture. So if you go to Amazon, for example, Amazon.com, Amazon, as I said earlier, It is offering you a service where you can see the entire catalog. It is offering you the service where you can see the cart, your all the orders which are currently present in the cart, but you haven't paid the money for that. Then they have a section where you can see all the orders which you have made. They have a section where you can authenticate yourself. So Amazon is a big application, but they have so many services to offer you. They have a cart service. Okay, they have a service where you can see your entire catalog. In Amazon, you have one service where you can see some of the movies and all mini TV. Okay, they have some this kind of option. They have an option where you can do entire your billing. There's an option where you can maintain your entire order history. Okay, so one application when offers so many services, so this application become very bulky, and managing this kind of application is very hard. Okay, so what we come up with, we change our architecture. So one way could be that we can deploy this entire application, or we can build this entire application as a single unit. So I will create one single code base. In that single code base, I will create multiple files. In one file, I will have a logic of catalog service. In one file, I have a logic of my mini TV or billing service, order service, card service, whatever. Okay, this is called as your monolithic application. Monolithic application where you put all the feature in a single unit. And you imagine Amazon is such a big website. Let's say in the Amazon mini TV service there's a small bug. This small bug. So if you are using it as a single unit, as a monolithic application, okay, you have a bigger application, you are using it as a monolithic application, and let's say you have created multiple files. Each file has a code for your specific service, and if you will have an issue in any of your code, any of your file, your entire server will crash. So in monolithic application, you have single point of failure. Okay, if your any specific feature got failed or has some bug, your entire application will be down. So although the issue was with my mini TV feature, but still my cart feature, my catalog feature, my billing feature, my order feature, all of them are right now down. They are not accessible. Okay, so this happens a lot when you have a very bulky application, when you are offering so many things as under the roof of one single application. So in this case, we come up with a different architecture, microservices architecture, where we decide that we are going to build all these small features separately, independently. Means there will be a separate code base for my order service. Then in Amazon, you also have a service where you can watch some what we say advertisement, right? They show you some advertisement where they advertise some product. Okay, so Amazon has offering so many things. So what Amazon can do, they can create the code for each one of them separately at a separate place, means individually you can say, and then we will also deploy them individually. Means for cart service, I am going to create one separate Docker image for my cart service, and then I will launch. If I want to launch my cart service, I will create one Docker container for my cart service where my cart service will be running. Only my cart service will be running. In one container, my catalog service will be running. In one container, my mini TV service will be running. In one container, my billing service will be running. And in one container, my order service will be running. In one container, my advertise service will be running. And if these services wanted to communicate with each other, then they can communicate via APIs, via gRPC protocol. We have different ways available, which your developers will take care of. So if they want to communicate with each other, let's say whenever you select a product from catalog, you put that product to your cart, then your catalog service is communicating with your cart service. When you take a particular product from cart to your billing, you want to pay money for that, then you are communicating with between your cart service and your billing service. So they can communicate with each other via some APIs. But the benefit now is each one of them are now deployed independently. Each one of them are running in a separate container now. Now, let's say mini TV container has some problem, some bug. This container may be down, but it will not impact your other containers. Your other services will still be running. So now you don't have a single point of failure. Okay, we have divided our bigger application to smaller microservices. Now these microservices we can deploy independently. They will work independently, and they can also scale independently. Scale means, let's say there's some sale going on, okay, right now in Amazon. So suddenly you want more and more load is there on your catalog service. People are watching different kind of product. They are comparing the product. So in that case, you wanted to scale your this particular service, catalog service. So in that case, you can launch more containers just for this catalog service. because your catalog service is currently in more demand. More load is there for catalog service. So you can launch more containers. Now, let's say very minimum people are watching your movies or series in mini TV. So mini TV, let's say only 2 containers are running because you have less load. But for catalog, because there was a huge load, there's a sale going on, so you can launch more and more containers. So now your application can be also scaled as per the requirement. Let's say in Instagram, we have reel service, we have post service, we have status service, we have notification service, we have chat service. Nowadays, most of the people are watching reel service. So for reel service, they would have created one Docker image and they would have running multiple millions or hundreds and thousands of containers. But for let's say notification service in Instagram, you have an option to get notification as well. Very limited load is there. Only few replicas for that purpose service will be running. So now in this application, a bigger application which is offering so many services, we can scale them independently from each other. Okay, and here Docker will help us. So microservice is one of the architecture. If you wanted to implement it, you will need to create your Docker images, and then you will need to create your Docker containers. And you will see in this kind of architecture, in the end, you will end up with hundreds of containers. So many containers will be running. Okay. And managing these containers for a human being is not possible. That's why here we need one more tool. And this tool is very powerful tool that is called as container orchestration tool. Okay. Kubernetes is one of the example of it. So what Kubernetes does, Kubernetes says that you have now hundreds of containers. 50 containers are running for catalog service. 20 containers are running for card service. Okay. For a human being, managing this is not possible. So Kubernetes is the one which is going to manage these containers life cycle in your behalf. So now onward, like till now, I was directly communicating with Docker. But once I will use Kubernetes, I'm going to communicate with Kubernetes. It means I will say Kubernetes, can you please launch one container for me? Okay, this is my Kubernetes, where my, let's say, real service will be running. So Kubernetes will create it for me. Let's say suddenly load increases, so I can also enable auto scaling in Kubernetes. So Kubernetes will automatically detect there is more load. They will automatically launch more and more replica of your container where your real service is running. So the first benefit of using Kubernetes is auto scaling. If you are not using Kubernetes, you are directly using Docker. In that case, you will have to manually scale your application. Let's say I was running only one container. I was using Docker run command. I was running my container, let's say web OS image. Suddenly I got viral. So I will have to again use Docker run command and run one more container of this from this image, one more container from this image. I will have to do it manually. And a human being can't sit 24/7 in front of a screen and keep on monitoring how much load is there and all. But Kubernetes can do it because it's a program. Second thing is, let's say for your real service, there was a container running, but due to some issue, due to some leakage, memory issue, this container got destroyed, deleted. They start getting failed, right? So in this case, Kubernetes have a way where they can do auto healing. Healing means if any failure will happen, Kubernetes will automatically detect it and Kubernetes will try to restart your containers, relaunch your containers to fix it. Kubernetes will automatically relaunch your applications to fix it. Kubernetes can do it. Okay. So Kubernetes will give you scaling, healing, and it will always make sure that your applications and your servers are always available. You don't have a downtime. So I can ask Kubernetes, you have to make sure, I will give a limit. Kubernetes, you have to make sure that 10 replicas of my this particular service should always be running. So let's say 10 replicas are running, means 10 containers are running for my real service. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As your any of the container will get deleted, your container was destroyed, your container was deleted or cancelled or was stopped due to any kind of issue, Kubernetes will automatically detect it. Okay, Kubernetes will automatically identify that, okay, you asked me for launching 10 containers, but right now some issue happened and only 9 containers are running. One of the containers is currently down. So Kubernetes will automatically find out that 10 is not equivalent to 9. You asked me to launch 10 containers, now only 9 containers are running, but they will automatically take a decision to recreate that container or relaunch that container. Okay, so very powerful tool. In real world, what you will see that we don't manage our Docker containers directly, we manage them via Kubernetes. So Kubernetes can help you to manage the entire life cycle of your containers. So if I search here container orchestration tools, so you will see Kubernetes is one of the pioneer over here. Okay. So if you go to your document, so you can see container orchestration is the process of automating the deployment, management, and scaling as well throughout the life cycle, making it possible to deploy software in a consistent manner across many different environments at scale. So in real world, when you have billions of consumers and you wanted to give them service, millions of consumers you have, okay, so you will need this kind of tool which will scale your application as per the requirement. Okay. And let's say you are running your Black Friday sale, or let's say you real service was very much in high demand. And let's say usually what happened, they were running 10 replicas, 10 containers for real service. But let's say after 12 a.m., most of the people will sleep. So now we have less load on the real service. So automatically Kubernetes will get to know that now we have less load. So they will start removing the unwanted containers to save cost. So they will only do or only run those many containers which are required. So they can do scale out as well as scale in as per the requirement. Kubernetes can do it for us. Okay. And the question which you were asking over here, Sarad, what we will do for Kubernetes also, we are going to create multi-node cluster. Multi-node cluster means we will have one particular system where your Kubernetes master node will be running, which will be taking care of all the decisions. Okay, how to launch containers, how many containers should be running, whether the container lifecycle, whether container is still available or not. Okay, everything will done by Kubernetes master node. You are the DevOps engineer. You will do all your communication with the master node directly. So you will give all your requirement to the master node. Behind the scene, your master node will be connected with multiple worker node. Okay, and in these worker nodes, your containers are going to be created and your containers are going to be running. Okay, let's say you have more load, so you have to create more worker nodes as per the requirement. So you can create a pool of your worker nodes. As the load increase or your load decrease, you can keep on increasing and decreasing your virtual machines. And then in that virtual machines, how many containers I have to create? This container will be for my real service. This container is for my post service of Instagram. So your Kubernetes can decide it. So your Kubernetes is going to distribute the traffic between your multiple worker node, and Kubernetes can also help you to provide you a load balancer. So your load can be distributed into your pods. So if you have multiple pods running for a particular service, okay, your load your distributed load between them. Again, Kubernetes can do it for you. Yes, so Kubernetes is capable of creating Docker containers with the existing Docker image. The only requirement what Kubernetes asks from you is, please give me your image name. Please give me your template name. What kind of container you want to create? Please give me your code. So you have to provide your image. That image Kubernetes is going to use to launch your containers. Okay. If something happens, some loss happens, then from the same image, Kubernetes is going to launch a replica of it, a copy of it. If something happened to your current one, Kubernetes is going to launch a replica of it. Okay, that's what Kubernetes will do. Yes, that's what you are saying correctly, Ronak. We can do that. So as your load increases, we can add a load balancer. Now in Kubernetes, we have support for load balancer as well. And today's practical also, you will see we are going to create a load balancer where my load balancer is going to distribute the traffic to my containers. Okay, so we'll do that as well. Okay, we'll see the load balancer as well. So guys, I think let's start with the Kubernetes setup. Again, Kubernetes is a very vast topic. I can speak on this particular topic for hours, but let's come to our main agenda. We will see a practical of Kubernetes. Okay, so if you understand this practical, you will have a decent knowledge of Kubernetes, and you will be interested at least to learn more about Kubernetes, and you can learn it from any of the platform. Okay, so let me give you. Let me first create a Kubernetes cluster, a Kubernetes engine, and then in that Kubernetes engine, I'm going to do everything. Yes, so if you're storing your image anywhere, like right now, I was using Docker Hub. Whatever images I was storing in Docker Hub, Nanda, all of those images were public image. Any in this world can download them. But whenever you will be working in a company, whatever image you will create for, let's say, your real service, you will not make it open source so anyone can come. So you will store it in your private registry. Only your company's members will be able to use it. In that case, that registry password you will have to give to your Kubernetes. Obviously, otherwise, how Kubernetes will fetch that image? So you have to give that access, password, and everything to Kubernetes. Then Kubernetes will be able to download it, and from after downloading it, Kubernetes will be able to use it. Okay. So cluster is like whenever you have more than one system, then we call them together as a cluster. Cluster means a couple of things when added together as a bigger unit. Why we are considering cluster over here? It's very important concept. Let's say I am running one virtual machine. I have only one virtual machine. In this virtual machine, I have configured it as my Kubernetes. Let me use a different color. This yellow is very light. Let's say this is my virtual machine. Base will be always virtual machine. Okay. Then this virtual machine I am configuring as Kubernetes worker node. And then I will have master node, which will take care of all the master related programs, all the decisions and everything. And here in the worker node also, there will be an agent of Kubernetes running so that my master node can manage this worker node. Let's say you launch all of your containers in this virtual machine. And this, let's say this entire virtual machine got deleted or this entire virtual machine got crashed. There may be maybe an issue with your storage, your entire hard drive got crashed, okay, your entire oxygen got crashed, then whatever you were running, whatever containers you were running, everything will be deleted because these containers were running in top of a virtual machine. If your entire virtual machine itself is down, then obviously all of the containers will also be down. So it is an example of putting all your eggs in a single basket. If you put all your eggs in a single basket, if something happened to your basket, everything will be destroyed. That's why here we go with multi-node cluster. We launch multiple virtual machines. Okay. And there's a very less chance that at the same time, all these virtual machines will destroy or all these virtual machines will crash. It's a very less stress, not possible. Okay. So what I will do, if I wanted to launch my real service, so there will be one pod of real service running in this virtual machine. Few pods of real service will be running on this virtual machine. Few pods of real service will be running on this virtual machine. This virtual machine. So it is distributed over here. So even if this virtual machine also get destroyed, you don't have to worry. You still have some pod of your real service running in your other worker nodes, right? That's why we go with multi-node cluster. Okay, because we can distribute it, and even if there will be no single point of failure. Okay, because if we put everything on the same system, and if your entire system got down, because there is no guarantee of the hardware devices. If your entire system got down, everything will be down. You can imagine I was using Amazon.com, and suddenly Amazon was putting everything in one server and their server got destroyed. And you can imagine my entire Amazon website is not working. It will be such a mess, right, for the company. So for these companies, every time some of the virtual machine may be getting destroyed, some of the virtual machine may be getting some hard disk issue, data issue, but they keep on replicating it. Same thing we did it for Jenkins as well, if you remember. For Jenkins also, we created a multi-node cluster. Because if I didn't create a multi-node cluster, you can imagine my developers keep on making the changes and only one system is running for Jenkins, which is taking care of all the things. In that case, what if my entire Jenkins system is down? Okay. Or even guys, we can create a replica of master node as well. Okay. So if anyone want to go in that direction, you can go. Okay. So if you are running multiple jobs, let's say suddenly hundreds of developers in my company, because my company is huge, we have hundreds of developers. All of these developers have triggered their respective pipeline. Now, all these pipelines I can't schedule in the same system. My system will get overheated, overloaded, and it will crash. That's why we were configuring a multi-node cluster for Jenkins as well. Same thing, Jenkins was just for executing your pipeline. Kubernetes is the place where your containers will be running. Okay, so Kubernetes will come under your deployment part. So today we are going to create one cluster of Kubernetes. Cluster means it will configure both master and worker node. So you can do it anywhere. But right now in AWS, we have a very powerful service, and the service is called as EKS. So guys, if you have heard about EKS, or you maybe heard about AKS. In Azure, we have AKS. In AWS, we have EKS. EKS means Elastic Kubernetes Service. So if you wanted to create a Kubernetes cluster in AWS Cloud, okay, you can use this service. If you wanted to create the entire cluster by yourself, everything by your hand, you can do that as well, but that will require good knowledge of Kubernetes. That will be called as on-premises cluster configuration. But right now, I'm going to use this service, EKS service, where my cluster will be launched in AWS account. Okay, a fully managed Kubernetes cluster with infrastructure will be launched in AWS Cloud, and my AWS Cloud will be managing everything for me. entire setup will be managed via my AWS cloud over here. So let me initiate this cluster. Once this cluster will be created, I will continue my discussion because creating a cluster will take around 15 to 20 minutes, 10 to 15 minutes at least it will take. Okay. So I am going back to my worker node, guys. Sorry, let me go back to my worker node. And from here, I am starting the practical or the goal of this workshop, which was to deploy a movie streaming application like Netflix on Kubernetes. So here the practical starts. What you need to do, I am going to my worker node. Okay. And guys, I have a repository as well for the project, which I'm going to show you now. So if you go to my repository, okay, in my repository, you will find, sorry, in my GitHub account, you will find there is a repository called as Movie Streaming App DevOps. So this repository has my entire source code. It has everything for running this particular project. So I will explain you this project line by line. So don't worry. I'm giving you the repository link. You guys can fork this repository or start this repository, and this repository we are going to use today. Okay. So first of all, ignore all these things. Just move to your README file over here. This is how my architecture is going to be. Okay. I will come to this architecture in a minute. First of all, I just wanted to start my Kubernetes cluster because it will take 10-15 minutes. So we'll have some time to discuss about the architecture and other stuffs. Just come to this particular part over here. Configure AWS EKS cluster. If you wanted to configure AWS EKS cluster, you have to install one tool called as EKS CTL tool. This is one of the command line tools from AWS for managing your EKS cluster. You have to download it. So copy this command, go back to your worker node, which you already had for Jenkins configured. Let me just do here. Okay. And here I'm going to paste this. What it will do, it will install one program for me. This program is called as EKS CTL. This program or this tool will help me to create a EKS cluster, Kubernetes cluster. That's why I'm installing it over here. Once you install this program, the next thing you have to do is, because right now I'm in a virtual machine and I wanted to create something on my AWS cloud. So I will also have to authenticate myself. Okay, I'm in a virtual machine. That's why in your AWS, we have one service called as IAM service. This is a very powerful service. From the service, you can manage all different user accounts, their permission, their access, everything can be managed from this IAM service. So in your company, what usually happen? Your company have one AWS account, one AWS organization account. Then whenever you join your company, what they do, they add you to their IAM service. So you can see, let's say in my company, I have 15 employees. So for each of these employees, I can add them into my AWS cloud because I have one cloud. One cloud means this is cloud of my company, let's say you can imagine. So my employees are not going to create their own AWS cloud. They are going to use the AWS cloud for which is set up for company. So in this case, what your company will do, your company will create multiple users. Okay, let me create a new user, for example, create user. And let's say I will create a user, Sudhanshu Ops. So a new user will get created. Okay, I will click on next. Then they are saying you wanted to onboard a new employee to your AWS account. He's a new user. What kind of permission you wanted to give him? Set permissions. Okay. Or do you want to add him in a group? So let's say in your company, it may happen that all the employees who are developers, they will be in a dev group. All the employees who are managers, they will be in a managers group. So it can be further used for managing your employees and your users in a much better manner. Right now, I will just go to attach policies directly, and I'm going to attach one of the policy. This policy means what kind of access you want to give it to this user. So if it's a junior developer, for your junior developer, you don't want to give him database access because he may make some trouble over there. For a junior developer, you will only give him access for EC2 service. You will not give him the access for database kind of services. Only the senior people will have that access. So here we have a big list from where we can decide what kind of access I want to give to this particular user. Right now, to make this practical, very clear, and very easy, I'm giving myself administrator access. Administrator access means I will have all the access, almost all the access in this cloud. Otherwise, you can add access. Let's say you wanted to give him the access only for EKS service. So you can search for EKS over here and give him only the access for EKS service, not for any other service. Okay, but what I will do, I will give the administrator access to make everything very simple, because we are not in IAM class right now. So just make it like that. Click on next, and your user will be created. Okay. Now for this user, you can see here my Sudhanshu ops user is present. Okay. If you want to do something from this user, you can go to security credentials, because you have to log in. And here you can enable MFA as well, multi-factor authentication, OTP and all. And then here we have an option of access keys. Okay. So if I wanted to log in to my AWS account as a Sudhanshu Ops user, so I will have to create a set of access key and secret key, means a username and password. So I can click on create access key, and then they are saying, why are you creating it? So I'm saying that from my command line interface, I wanted to run some AWS command, and that's why I need this particular credentials. Just tick this, just mention I confirm, click on the next button, click on the create access key, and the AWS will give you one access key and secret key. These are your credentials. Don't share this credential with anyone, otherwise they will be able to log into your AWS account, and they will be able to do anything. Okay. So right now in my case, I will copy this access key. I will go back to my EC2 instance. Now from my EC2 instance, I am going to log into my AWS cloud. And for that, we have a command AWS configure command. And then whenever you do AWS configure command, they will ask you four things. The first thing is, what is access key ID? I have already created it. I will just paste it over here. Then what is your secret key? I will copy the secret key. I will paste my secret key as well. Then in which region you wanted to do setup, like in AWS cloud, in which region do you want to work? I'll say in my Mumbai region. So for Mumbai region, we have a code called as AP-South-1. Same code you can write over here as well. That my default region is going to be AP South 1, that is Mumbai. But if I want to change, I can change it as well. So now I'm going to use my AWS cloud from this command line interface. So AWS is your cloud. If you wanted to do anything in your AWS cloud, we have three ways. One is from web UI, one is from CLI, and one is from API. So right till now, I have used my AWS cloud from web UI. Means I have logged into AWS cloud. This kind of interface I got. I'm using my mouse. I'm clicking on the services. I'm searching for the services, and then I'm creating the EC2 instances. Everything I'm doing it from my web UI. But if you wanted to do anything in your AWS cloud, web UI is always very slow, because you have to manually click. Okay, you have to remember all the sequence. If you want to do it from CLI, so in that case, you will have to mention, you have to give your credentials. Now I'm going to use my AWS cloud from CLI. So they are saying that whenever you will run a command from CLI, in which format you want to get output, I'll say, give me the output in JSON format. That's it, guys. Now I will clear my screen. Okay. And I have logged into my AWS cloud. Okay. I've logged in over here. What is the next command I have to do? So from here, you can copy one more tool called as kubectl. I will explain you this tool, what exactly it is. Just copy it for now. Okay. Because I wanted to start my EKS cluster configuration. It is a time-taking process. So this is the main command which is going to create your EKS cluster, your Kubernetes cluster. Cluster means it will create a master node and worker node both. Just copy this command and run this command for now. Okay, this command will take around 15 minutes to complete. And meanwhile, this command is getting completed. I will show you, I will explain you everything what I did till now. Okay, I just wanted to start this one. Okay, that's it, guys. I have run this command. Now this will take around 10 minutes to create my EKS cluster, because behind the scene they have to set up so many things. Okay, so I have initiated, okay, my cluster creation. Now, Hitika, you are saying, I didn't understand, we have master worker in Kubernetes and then again have a master worker in Jenkins too. We have seen. No, so you can have one system which may be working like a worker node for your Jenkins as well. He's working like a worker node of your Kubernetes as well. You can do that, but usually we set up a different worker node, a personalized worker node. Why? The reason is the worker node which you will need for Kubernetes, that worker node must have a Docker installed. Okay, they must have some particular things installed. But the worker node which you will need for Jenkins usually should have Git installed, because you are going to clone your repository. It should have, let's say, some of your Python package manager should be installed. So there is different requirement for the worker node. Okay, if you want, you can use the same worker node for Kubernetes and Jenkins as well. But usually we define two different worker nodes, two different kind of worker node I hope this is clear, Ritika, right? Okay, so Ronak, in industry, we usually don't use web UI because web UI is very slow. You can see I have to click it over and here. This web UI is only for your learning purpose. We can use web UI, it's not a problem. In real world, we usually use CLI or we use some template. So if you wanted to create any of the services in AWS cloud, we can use it from template as well. There's a tool Terraform, if any one of you have heard about it. So we usually use Terraform kind of tool to make the changes or create infrastructure on a cloud. We don't do it from a web UI or something. So we usually use Terraform kind of tool, which behind the scene creates some you can say template, and by that template they create the infrastructure. We'll not go to that direction. Again, it's a part of DevOps, but it's not part of our today's agenda. Terraform. Okay. Or you will see that mostly we will use CLI. Okay. That's what we'll do. Now let me explain you the entire project architecture. What exactly are we doing over here? So let me take a screenshot. Now let me start from my basics of this repository. Let me take a screenshot of this README document or this architecture which we are going to create. Okay. So guys, I have a very simple application. This is a full stack application which has your front end and back end present. Okay. So means I have a code for front end as well. Front end is written on HTML, CSS, and JavaScript, client side JavaScript. And backend is also written in JavaScript in this case. We are not using Python over here in this practical. So backend is also in JavaScript. Then we have a database as well. And for database, we are going to use MySQL. This is going to be our setup. And what exactly is our application? So our application is, the application will give you a UI. Okay. It will give you a form. Let's say I am the admin of this application. What I will do, I will go to this form. This form will be your register.html form. So let's consider I am a Netflix owner. I'm a Netflix admin. So whenever a new movie I have to release in my platform. So what I will do, I will come to register.html file. I will fill in all the details, like what is going to be my movie name, what is going to be my movie genre, what is the rating of my movie, what is the movie thumbnail, and then what is the movie, let's say video file. So I am creating here one admin page where you can register all the details about a movie. And as you will do the save button over here, this movie details will be stored in your DB. And now anyone who will come to your website at a page, okay, gallery page, then they will be able to watch your movie. Okay. So I just tried creating a similar thing how Netflix does. So someone will be registering a movie, then you will be watching the movie. That will be the application. How it will do? So this is the architecture, entire architecture. You will have a development team who will write the code. Let's say in my case, I have written the code. I am a developer. So I will create my code. Once my code is created, what I will do, I will commit my code to GitHub because I want to work in a collaborative environment. I have so many developers. We all want to work together. I will put in GitHub. As I will put something to GitHub, automatically my Jenkins will be triggered. What Jenkins will do, Jenkins is going to execute my test cases to make sure whatever code my developers have created, it is working properly. It don't have any bug. Once my test cases have been successful, then what I will do, I will build a Docker image and then I will push that Docker image to Docker Hub so that we can use it in the next step. So we are building, and we are pushing the Docker image. So we'll first test our application. If our application is properly being tested, then we will create a Docker image over here. And this Docker image we are going to give to our Kubernetes. We can give it to directly to Docker as well, but in that case, you will have to manage the entire life cycle of that Docker. If that Docker system got crashed, you will have to restart it. If you wanted to scale it, you have to do it manually. But Kubernetes can do everything for you. You just have to give the instruction. So here I'm going to use Kubernetes cluster, EKS cluster, which I have just initiated. Then here what EKS cluster will do, it is going to launch two containers for you. In word of Kubernetes, it is also called as pod. It is going to launch two pod for you. So guys, for now, just remember pod is almost similar to your containers. Although pod have a different concept, in a pod we can have more than one containers as well. But right now, I don't want to confuse you. So just think pod is similar to your container. Okay, so here there are two containers which are going to be launched. In one of the container, my front-end application will be running, means my front-end code will be running. And in a separate container, my back-end code will be running. So I'm trying to give you a basic idea about my microservice architecture. Also, it's not a real microservice architecture. In a real microservice architecture, there's so many different microservices. But just to give you a feeling or taste of it, okay, what we are doing, we are not running our entire application to a single container. We have distributed the load. My front-end application will be running in a front-end container, in a different container, and my back-end Node.js will be running in a different container. Okay, that is the thing. Then I will need a database where I can store all my data, like whatever metadata my user have filled in this register.html file. We have to store it in a database. So my backend container, my backend pod, my backend application, where I have the entire business logic, will be connected with one of the database in AWS. And in AWS, we have a service called as RDS, Relational Database Service. And via this service, I'm going to create one MySQL database, and this MySQL database, I'm going to connect with your Node.js server. So your Node.js server is going to update or upload all your metadata in your MySQL DB over here. But now you tell me, in MySQL DB, can I upload my raw data as well? Can I upload an MP4 file, my video file, or my image file, PNG file? Can I upload a PNG file or MP4 file in a MySQL database? What do you guys think? Okay, so MySQL database I'm going to use, we can't do it, right? Okay, it's good that you guys are aware. Why? Because in your database here, you can only store your metadata. So there will be a schema which we will be following. There will be a table we will create, and here we will only store our schema, our metadata. Any kind of raw data we can't store over here. So where exactly we will store raw data? So we are using one more service of AWS that is called as Amazon S3. This Amazon S3 is equivalent to or similar to your Google Drive. So you guys are aware in Google Drive is an object storage service. Object storage service. And in Google Drive, you can store any raw data, right? You can, in Google Drive, you can upload a drag and drop a file, MP4 file, PDF file, whatever file you have. So whatever raw data I have, I'm going to upload it in my S3 bucket. So S3 is a service which is similar to Google Drive. So in Google, in GCP, in Google, you can imagine we have Google Drive. Okay. In Azure, we have blob storage. Similarly, you can think in AWS, we have S3 storage. So there is one more service, S3, which will work similar to your Google Drive. All the raw data we are going to store in Amazon S3. And like in Google Drive, whenever you upload a file, they give you a unique URL to access it, right? Similarly, my Amazon S3 is also going to give me a unique URL. And this URL I am going to store in my database. I will say that my movie name is, let's say, anything, ABCD. For this movie, the associated thumbnail is uploaded in my Amazon S3 bucket, whose URL is this one. For this movie, the movie video file is uploaded in my S3 bucket, whose URL is this one. So we are just going to store the URL of your, let's say, raw data in your database. So your data will be stored in your bucket, in your S3 bucket in this case. Okay. This is a very simple architecture we are going to follow. So now we have to create one database as well, RDS database, MySQL database. So in AWS, we can do that. So I'm taking you back to my AWS service. And here I'm going to search for a service called as RDS, Relational Database Service. So let me go over here. So now in RDS, I'm going to create one database instance. Okay. So I'll say RDS, I want to do one thing. I will go to database section. So I'll say I wanted to create a new database. Okay. So they will ask me, which kind of database you want to use? You want to use MySQL, okay, Oracle, PostgreSQL, MariaDB, what exactly? So let's say I will go with MySQL, a simpler one for now. Then which community version? So I will say I will go with MySQL community. Then which version? I am going with the latest version, whatever is available over here. Then they are saying you are creating this database for which environment? For production environment. If you want for production environment, then in that case, what will they do? They are going to launch multiple database instance behind the scene because they don't want to have a single point of failure. So they will launch again a multi-node kind of cluster behind the scene. There will be a primary instance and then there will be a standby database instance. If something happened to your primary instance where read and write operation is happening, then your standby instance will become the primary one. Okay, so do you want it for production system? Do you want it for dev and tests over here? Or in this case, I'm going to use free tier. So in free tier, what they will do, they will only run one copy of your database instance. They will not launch multiple copy of your database instance, because if you launch multiple copy of your database instance, you have to pay more. Okay. So here, if I select production one, they will launch 3 copy of my database instance, but it will also charge you more. You have to pay for that money. And they are also saying that almost 99.95% of time your database will be up, because entire database will be taken care by your AWS. It's a managed service. But I will go with the free tier just for learning purpose, you guys. So here, what they will do, they are going to create only one copy of my database instance. If something happened to this instance physically, let's say my hard disk got crashed, something happened, then your entire data will be lost. But that is fine for us right now, because anyway, we are using for testing. In production system, we can use this way, where they will keep on synchronizing your data with your secondary databases. Then what is the name? Database name we can give. That's database 2. Then what is the password you want to set for database? My username will be admin. Let me set a password over here as well. This will be my database password. I will recommend you to give a good password, but I am just giving a password which I can easily remember for now. Okay, they are saying it's a weak password, but that is fine. Okay. Now they are telling that okay, for this instance configuration, they will take 1 GB of RAM, 2 core of CPU. Behind the scene, this much network speed they can give you, because we are using a free tier. It's very slow. Okay. Behind the scene, they will attach a SSD storage of 20 GB, up to 20 GB of data you can store. That is enough for us. Okay. Connectivity, I don't want it from any institution right now. I will do it later. Okay. Rest of the things you can go with by default. You don't have to make any changes. Just go down. Okay. Go scroll down and just create your instance. And guys, this is for free tier. In free tier means they are saying for 750 hours, they will not charge you. So Amazon RDS free tier is available for you for 12 months. So if you use it within the limit, if you use only till 20 GB of SSD storage, they will not charge you. If you go beyond that, they will charge you. This is free to use. So just click on create database, and then your database will be configured. It will take some time. This is a database we are creating. To close this, this is the database we are creating over here, database 2. In some time, it will be up and running for us. The database is ready now. Then we have to also set up this kind of S3 bucket, which is similar to Google Drive I was saying to you, right? So I will go back here, then I will search for this service S3. Okay. So I'll search it. So guys, this is similar to Google Drive. It's an object storage service where you can upload your raw data. The first thing what you need to do here is you have to create a bucket. So you can click on the create bucket icon over here and then give a unique name to your bucket. So let me give a name, let's say GFG workshop day number 3. Okay, any name you can give to your bucket. Okay, this bucket name will be important, because in my one AWS cloud, I can have multiple buckets which I would have created for my different project, from a different application. So this is a new bucket I'm creating. Okay, right now by default they will block all the public access, but let me not block all the public access, because whatever movies or videos I'm going to upload, let's say I want everyone to have access of it. So I'm not taking this option right now. And then I'm saying I acknowledge that this will let everyone access the data of my bucket. I'm saying that is fine for me. Just click on create bucket and your bucket will be created. In this bucket, you are going to host, or you're going to put your raw data. So you can see this bucket is created GFG workshop day 3. I will click on this bucket. Okay. And here you can upload your file. In Google Drive also, they have similar option, right? So let me just search some of the file which I have. Let's say I have a, what's it, lion image. So I'm going to copy this lion image over here. Let me just do a drag and drop. That's it. So I'll copy this image, upload this image over here. And guys, like in your Google Drive, you have almost 15 GB of storage, which they give you for free. But in S3 bucket, they give you only 5 GB of storage for free. So if you use S3 bucket, if you store your data till 5 GB, they will not charge you. But if you start using more than 5 GB of storage, they will start charging. So anyway, whatever data we are going to store will be in KBs, very small data. So we will not have to worry. We can use it for free. This service also, you can use it for free. You can upload your data. So what you will see, my data is currently got uploaded. You can see here my one object, one data is present. My lion.jpg file is present. If you want to see this file, click on this. They will give you a unique URL to access it. You can see object URL. So I can copy this URL, and from this URL, I can access my image, whatever image I had, I can access it. But right now, you can see they are giving me access denied over here. Although I have made public access enabled. So if I go back to my bucket once again, let me go back to my bucket. And in the bucket, if you go to permission section, so what you will see, I have already blocked, like by default, they were blocking all the public access, but I have turned it off. I have said, please don't block all the public access. Let everyone access it. Okay. Why still I'm not able to access? Because in case of AWS S3, we have a concept of bucket policy. And via bucket policy, we decide who can access my bucket data and who can't access my bucket data. So it will be decided via your bucket policy. So here also, I have a bucket policy. Just give me a second, guys. Guys, someone is drawing on my screen. Please, guys, don't do this. Okay, so, okay. So here, what I will do, I will say, I will add a bucket policy. In the bucket policy, you can define by yourself who can access your application and who can't access your application. So a policy, a JSON policy you will have to give. Again, this is mostly done by your cloud engineer, or you can also do it. Okay, if you have basic knowledge of bucket policy. So what I did in my repository, the main repository, I have added one small option over here, one policy over here, which you can copy. This is a policy. So copy this policy. What this policy will do, this policy will allow everyone to access the data of this bucket. But let's say here you have a logic, you can click on edit button. Let's say here you have a logic, you wanted to add a logic where, let's say, only certain IP address you want to allow to access your data. Okay, then in that case, you can do it. Okay, but you will have to change your principle. Okay, right now you can see in the bucket policy, in a lame term, if you understand, we are saying effect is allow. I wanted to allow. Okay, what action I want to allow. So in this bucket, there can be multiple action can be done. One action could be put action, means anyone can upload data over here in this bucket. Anyone can delete the data over here. But right now I'm allowing only for the get option. That anyone can get the data from here, read the data from here, read only access I'm giving right now. Okay. And then in AWS, each service have their unique ARN number. This is called as ARN number, unique number. So I'm going to copy this number and then I'm going to paste this number over here. So you guys, similarly, you guys will also have to copy your ARN number for your bucket. So in the top, you will get your bucket ARN number. Copy this bucket ARN number, given this source section. What does it means? This particular policy will be applied for this particular resource in my AWS cloud. Okay. What people will be able to do? People will be able to get operation. They will be able to read my data. Okay. And then principal means who can read? I'm saying anyone can read. But here you can add condition. Only this IP address can read my data. Only if someone is coming from a certain range of IP address, block them. So all these things are possible in principal section we can add, but that will again be a different thing. I think someone is drawing on my screen, guys. Please don't wait. Let me do one thing. Okay. So they are saying there is an error occurred. They are saying, okay, why? There's one more thing. I am just giving my bucket name, but here I have to define that in my bucket, I have to use slash and then I have to mention star. Star means I want, this is my bucket name, bucket unique number, bucket unique identifier, you can say. I want in this bucket, whatever data I'm going to upload, for every data I wanted to set this particular policy. Star means every data. But let's say in this bucket, you have multiple files, a.jpg, b.jpg. You want only b.jpg, my external people will be able to access. A.jpg, they will not be able to access. So in that case, you can define only a.jpg file you should allow. But right now, I'm going to give it a star. Star means all the files which are present over here should be allowed. And then you can save your changes. As you will save your changes, if you go back here, last time we were getting some access denied. Now you can see we can load the data. Okay, so we have uploaded our data to S3 bucket. We have got a link over here to access our file. Now, this is a simple image file, but you can have a video file, MP4 file as well. As you will click on this URL, even you guys can also access it. I have made it open for everyone. You will be able to load the data. Okay, so we are going to use this S3 bucket in some time. Okay. So guys, I hope this architecture is now clear to you, what we are doing. Then you can go to overview section of this repository. You will be able to see what exactly this repository is doing. Okay. So this repository is going to have 4 pages. One is gallery, register, where you can register your movie. Gallery is the place where you can see all the available movies. Search is the place where you can search for a specific movie, and watch is the page where you can watch for a movie. Okay. Now for this, we have some code available. If anyone of you are aware about HTML, CSS, JavaScript, you can go to this folder, HTML folder. As you go to HTML folder, you will see 4 HTML file over here. Okay, gallery.html, register.html, search.html, and watch.html. These files have the entire front end code for creating your web pages. Okay, for beautifying it, everything is present in this particular HTML file. Okay, so in this HTML file, you can see what I'm giving a title over here. Then I'm defining a style over here, CSS over here. Then I'm giving the style for all our headers, headings, and everything. Then here you can see we are adding a JavaScript code over here so that my front end is going to trigger my backend. So this code will be developed by your developers. Okay, and once this code is ready, we are going to use it. So I'm not going to show you all the 4 files. You guys can check it later. These are the files which has my front end code. Similarly, backend code is present in your app.js file. This is the code which is again written in Express.js. Okay, so we are using Express.js over here. Okay, here in this Express.js, we are writing a code which will take the data from my front end, and this is the Express.js code which is going to store your data in your DB. This is the Express.js code, or backend algorithm, which is going to store all your raw data into your S3 bucket. So this is the entire code for that. If anyone is aware about JavaScript, you guys can read this code. That's this code. Okay. When I will be showing you the practical, I will give you a small glimpse of this code, what this code is doing, what kind of APIs it is creating. But for now, let's skip it and let's come and create the entire platform first. This is how your gallery.html file will look like. You will be able to watch or see a particular thumbnail, and you will be able to watch a movie. Okay, this is how the UI will look like once we will deploy it. So here we will have a front end, back end, and database. As we discussed, RDS we are using as a MySQL database over here. And then feature is we have multi-container deployment. We have multiple container. In one container, your front end will be running. In one container, your backend will be running. We have integration with S3, and we have a CI/CD pipeline also, which we are going to use. If you want to perform this practical, then what you will have to do, you should have Docker installed in your case. You must have AWS account because you have to create your credentials, and you must have Jenkins server also running. Then you can fork my repository, clone my repository basically after forking it. Okay. Then you can run your Jenkins server, and then you can also start your Jenkins worker node. So Jenkins will be required. Why? Because here we have a place where we are going to first test our code. So that's why Jenkins master and worker node will be required. In our case, we already have it. So we don't have to do it once again. These steps we can skip because we already have it. Then you will need to have a S3 bucket, which we have just created. I have just shown you how the S3 bucket will look like. And then now here is a small explanation about CI/CD pipeline. I will show you the CI/CD pipeline. How will it look? It's very straightforward. It's very simple. And then we have EKS cluster creation. Okay. So guys, we are going to use EKS cluster. That is our Kubernetes cluster. Okay. So what will happen? Once your Kubernetes cluster will be in running state. Okay. So this is my Kubernetes cluster. Once it will be in running state, it will be running in my AWS infrastructure. If I wanted to communicate with this cluster, I am a DevOps engineer. I am sitting in my own local laptop. How can I communicate with Kubernetes cluster? So for that, you will need a command line tool, and that command line tool is kubectl. Kubectl is your client side tool, you can say, a command line tool which will be used by your DevOps engineers to communicate with their Kubernetes cluster. That is the reason while configuring our Kubernetes cluster, we have also installed kubectl in our system. This kubectl will help us in, okay, it will help us in connecting our client with our Kubernetes cluster over here. So if you want to do anything communication with Kubernetes cluster, you will do it by kubectl. That is a command line tool. That's why here's a command to install kubectl for you. Once you have the kubectl, then you can create one EKS cluster. Okay. And this EKS cluster, guys, what is it's going to do? Because EKS CTL create cluster, they're going to create a cluster. Okay. Only one change you have to do, guys. While creating this cluster, you have to define in which VPC we are going to create it. Okay. VPC is like a virtual private cloud. It's like a local LAN you have. Again, it's a very big topic to discuss about VPC. But if you want to do this practical, you have to do a small change. Okay. in this particular command. So you have to go to your AWS cloud. My cluster, you can see it's still not created. It's taking so much time. I started it on 16.2 and now we are 16.28. Should be created by now. Let's wait. Okay, meanwhile, I will open VPC. Okay, I will open it in a new tab. Okay. So in VPC, what you will see, okay, this is rhyming over here. So in VPC, you will have a virtual private cloud by default created. You don't have to worry. This virtual private cloud is given by AWS by default to you. This is like a local LAN, you can say AWS have created for you. Here in the subnet section, you will see we have 3 subnets available. Now all these 3 subnets are public subnet right now, means they have the connectivity. They can connect via internet gateway and they can go to internet. You have to copy this subnet ID from here. Any 2 subnet ID you can copy. Okay, first and second you can copy, and then you have to paste it over here. Like I have pasted my subnet ID, so it will work only for me. For you, you have a different subnet ID. So you have to copy those subnet ID and paste it over here. Okay. Then let me copy this command and let me paste it in a notepad so I will be able to better explain you. This is how this command looks like. So what I did, EKS create command. This is my cluster name. I want to get in Mumbai region. This is a VPC subnet. This subnet you have to replace with your subnet ID, which you can retrieve from here. Your AWS cloud, retrieve this subnet ID from here and replace it. Okay. Then here you can see they are going to create some worker node as well for us. So one master node will be created and 2 worker node will be created. Why 2 worker node? Because here you can see we have mentioned that how many worker node you want. So to Kubernetes, I said please launch 2 worker node. Then here you can see I have also added a minimum value and maximum value. So I said minimum only 2 worker node I should have. Maximum I can make, let's say 10. Right now I made it 2 to save the cost, but I can make it 10. So what will happen? Here there will be an auto scaling group created at AWS level. If your virtual machine is occupied, fully occupied, okay, your virtual machine is overloaded, your virtual machine got terminated, then your auto scaling group is dynamically going to launch a new virtual machine for you. So you don't have to do your virtual machine configuration as well manually. There's a service auto scaling group in AWS that will take care of it. Okay. So you can mention that at max you can launch 10 virtual machine. Don't go beyond that. But right now I just set it 2, so make it simple. Then whatever virtual machine we are going to launch, they will have a size of 20 GB over here. And then whatever, because they are going to create 2 virtual machines over here. And then you also want to have a connectivity with those virtual machines. So they will also ask for the public key, like which key you wanted to give. Via this particular key, you can log into your instance. So you remember while launching a EC2 instance, we always have an option to provide a key over here, right? So whenever I create a EC2 instance, I always have an option to provide the key. This time, this EC2 instance will be launched dynamically via auto scaling group in AWS. They will launch this EC2 instance. So they are asking me, you may have multiple key available in your AWS cloud. Which key you wanted to use for launching this EC2 instance? Because if you do this EC2 instance, you will have to use the same key. You can see here in the key pair section. In my case, I have so many keys available. So you have to find any of the key which you have created, and you have to give that key over there. In my case, I already have a key whose name is DevOps. So you can see DevOps. This is a key somewhere. DevOps key is there. That's why here I have given a key name as DevOps. This you will have to change with the key which you have in your system. If you have a key with a different name, you can change that as well. Okay. Once you do this, your entire EKS cluster will be ready. That is all what we need to do. Let's see whether my cluster is now ready or how much time is still. Usually it don't take this much time. How much time it took? 16 to 16:32, almost 20 minutes it took. It should not take this much time. Okay. So what happened? Let me go to my EKS service as well. Let's see. In my EKS service, do I have anything? Elastic Kubernetes service. So usually take 10-15 minutes. Okay. So you can see in my EKS, here if I go to cluster section. Okay, guys, don't draw anything on my screen, please. Okay. So here you can see in the EKS 21 cluster is there. So my cluster is created, but my cluster must have a worker node as well. So my master node is created, but my worker node is not getting created. That is causing the problem. Okay. My worker nodes are not yet created. Otherwise, they would have been shown over here. You can see I asked for 2 worker nodes, but both of the worker nodes, they are still in the creating state. They're still creating it. Okay. So they're still doing it. Let's wait for a few more minutes. If it don't work, then I will have to make some modification over here and I will have to recreate my cluster because this much time they should not take. Okay. Once your cluster will be ready, now we can do the setup. Okay. And setup will be something like this. We are going to use Jenkins. So first of all, from GitHub, my Jenkins pipeline will be triggered. And guys, I will need at least 20 minutes to complete this practical. So if you are interested to complete this practical and to see this end-to-end pipeline practical, please wait for 20 more minutes. I will complete this practical today, and then we will conclude this batch or this particular training. Okay. So I will need some more time. Let me just wait for a few more minutes. Meanwhile, let me show you my Jenkins file. So if I go back to my repository, here, guys, if you remember, when I was using Jenkins for my last practical, what I was doing, I was going to Jenkins. Where is my Jenkins server running? My Jenkins server is running over here. I was going to Jenkins. Then in Jenkins, let me again log in to my Jenkins. I may have logged out. Okay. So here I was going to configure section. Okay. And then I was adding my entire script. You can see I was adding my entire script directly over here. But in real world, we don't type our entire script directly over here. In real world, what we do, we create a file. In that file, we put all our scripts, all our steps, you can say, and then we give that file to our Jenkins to use it. In this case, we call it as Jenkins file. That's why in repository, you will see we have a file called as Jenkins file. So whatever script I was writing manually over here, I will copy this and I will put this script over here. This is my pipeline script, you can say. Now I have put this pipeline script on a file called as Jenkins file. Now I will ask my Jenkins to read this particular file, and from this file, please create a pipeline for me. Okay. So here, this is a pipeline script which will be used for creating my entire pipeline or my job. Okay. And what this pipeline is doing, you can see the first step, what it is doing is it is cloning my repository. Then what it is doing, because here I'm using Node.js, so I have a test case over here, app.test.js. So till now we were using a test underscore app.py file that was a test case for your Python application, but this is a test file for your Node application. Okay, that's why you will see in your Jenkins file where I have done my pipeline script. The first thing what I'm doing after cloning my repository is I'm installing Node.js. I'm doing the npm install command to install all my npm Node.js libraries. Okay, these libraries or dependencies are defined in package.json file. So in Node.js, we usually have a package.json file. In Python, we have a requirement.txt file. Okay, here we have a package.json file. So we'll install it and then we will run npm test command. This command is going to test or perform all the unit testing for me. And once the unit testing is completed, then I will proceed with the next step. What is the next step? Let's say my unit testing is completed. Now I wanted to build my Docker images, and then I wanted to push my Docker images to Docker Hub. That is my second step, which I want to do over here. Okay. Let me check meanwhile, is it ready? So it got failed. So my cluster is not created, guys. Let me do a small change in my cluster. Let me just do one thing. Okay. Okay, let me just change some of the things in my cluster. Let me create it once again. Let me give a different name to it. Let me give a 25, let's say. And default node type is t3.medium. That is fine. Number of node is 2. Volumes. Okay. Let me use default node group 1. Okay. So I just changed my node group name and my cluster name, and let me try creating it once again. Okay, so I may have created so many clusters, so they might be taking some time or it's getting failed basically. Okay, they got some error. They were not able to create your worker node. So I will delete this cluster. Yeah, we can delete this cluster. Let me copy this command and let me open one more terminal of this particular EC2 instance and let me delete this cluster, folder cluster, and let me launch a newer one. So it's a very rare situation, guys. It may happen with you sometime because we are using free tier account of AWS. So we have limited, you can say, budget what AWS is giving to us. So in my case, although I have exceeded my free tier limit, I am paying AWS for whatever services I am using, but they may sometimes restrict you. So whatever cluster I was getting earlier, I'm deleting it. I'm getting a newer one with a newer name. Let's see what happens this time. Let it complete. Meanwhile, let's come back to our discussion and let's complete this Jenkins file discussion. Okay. So, Sarif, you are saying what about the virtual machine when we run on AWS with using the login through PowerShell and AWS or having Docker for different instances? I didn't get it. So, Docker is Docker, the technology of Docker, that is containerized technology, is called as OS level virtualization. So, virtual machine and Docker is two different things. Virtual machine you have to create. In top of virtual machine, you have to install Docker, and then you have to use Docker for creating your containers. Okay. And if you want to log into your virtual machine, you should log in from your PuTTY or from your command prompt or the way I am logging to my EC2 instances from this kind of web viewer. That is also fine for now. Okay. So if you want to scale your application, you have to do two things. You will have to scale your virtual machines as well. You will have to launch multiple virtual machines. In my case, when I'm creating this EKS cluster, there is a service called as auto scaling loop, which will scale my virtual machines as required. And then Kubernetes is the one which will scale my pod as per the required. Okay, so pod will be launched in top of your virtual machine. If we don't use containers or if we don't use this Docker technology, then what will happen in top of one virtual machine, mainly you will be able to run only one application. Because in top of one virtual machine, if you want to run multiple applications, then how will you take care of security of this application, isolation of this application? Docker gives you this feature where you can launch more than one containers, or more than one services on the same virtual machine. Okay. Let me come back here. Once your test cases are completed, what is the next step you will do? You will build your images. Guys, please don't worry about the attendance. I'm not sure why you guys are so much thinking about attendance instead of focusing on the topic. Even if your attendance is marked and you are not able to understand the topic, so it won't make any benefit, right? So we can discuss about attendance things later, right? Okay, so the second step is, guys, Docker build and push. Okay, what we are doing here, we are going to run some of the commands. You can see some of the commands we are running. The first command is Docker build command. Okay, and here I am going to create two containers. One is for my front-end application and one is for my back-end application. Two containers I'm going to create. That's why here you will see I have two Docker file. If you go to your HTML folder, you will see in your HTML folder we have a Docker file. This Docker file is going to create your Docker image for your front-end application. And here we are using Nginx as one of the base image. Then we are copying all of our HTML file, CSS file into USR share Nginx HTML. That is the location where Nginx looks for all the web pages. Okay. Then we have a script as well, which we are copying over here. Don't worry about it. We are making that script executable and we are running this script over here. What this script will do? Okay. This script which I am using entry.sh. This script is going to help us to start our front-end server. Basically, your Nginx server will be started. So we have one Docker file which will build an image. From this Docker file, we will build an image for our front-end application. Now you will see we have one more Docker file. Now this Docker file is for your backend application. And my backend is written in Express.js, which is Node behind the scene. That's why here, because it's a Node application, so I'm using Node as one of the base image. Then here I'm creating one working directory. Working directory means I'm setting that whatever instructions I'm going to give now, okay, all these instructions will be applied from this particular directory in your Docker image. It's like you are changing your directory. You're setting a particular directory from where your commands will be executed. Then in Node.js, especially over here, we have a package.json file which have all of your dependencies. You can see we are using copy instruction. We are copying our package.json into our Docker image. Then what we are doing, we are using npm install command. It will install all of our dependencies defined in package.json file. And then we will copy rest of the code of my application. And then usually your Node.js server will run on port number 3000. That's why I have defined that my Node.js server will be running on port number 3000. Okay. One more thing is very important, guys. Whenever you create one application, in that application, you may want to store some kind of data. Okay. In that case, okay, we don't want it to do hard coding. Let's say here, in this case, my backend application needs to communicate with my MySQL DB, and my backend application also needs to communicate with my S3 bucket. Now, how my backend application can communicate to these things? For that, my backend application must have the credential of my database. My backend application must have my S3 bucket name. So these are some of the details which I don't want to hard code in my source code. Okay. That's why here we are going to pass this information as an environmental variable. So we are going to create a variable, and via environmental variable, we are going to pass or attach these things to our container because it will be dynamic. Okay. We can't hard code it in our container. That's why here you can see we have defined multiple things over here. Although for DB user, we have defined admin. Password also I have defined Red Hat. This is just for testing purpose. It is not my real password, which I have created for database. It's not real password. We will update this password field later when we will launch this container. Then what will be your database name and what will be your AWS region where you will create everything. So we are providing these immutable variables. Why? Because my backend application will need to communicate with my S3 bucket. If it need to communicate with my S3 bucket, it should know in which region my S3 bucket is running. What is the username of my database? What is the password of database? So here we have given a default value, but this is not a real value. We are going to change it, substitute it later. Okay. And then you can see in the last, we have our app.js file, which has the entire server information. We are starting our node application. Okay. And our node application will be started. This is our Docker file. If you wanted to use this Docker file, okay. So what we will do, we'll go back to our Jenkins file. So you can see in the Jenkins file, we have a step written where we are using Docker build command. And you can see we are tagging this image with my Docker Hub username. In your case, you will have to change it with your Docker Hub username. And then I have given a name to my image, movie, streaming, backend, some name I have given to my image. Then what I'm saying next is that I'm going to use latest version of this particular image. Okay. And then I'm going to build this image from the Docker file. So what it will do, it will build my backend image. Once my image will be built, you can see it is also using push operation. It's going to push this image to my Docker Hub. But because if you want to push this image to Docker Hub, so your Jenkins must be aware about credentials of your Docker Hub. Now here we can't hard code the credential. That's why here we are going to use one of the concept in Jenkins that is called a secret credential manager. So we are going to use one credential manager where we are going to set up our credentials. In this case, we are going to set up credential for Docker Hub username and Docker Hub password. Once I will set up this credential, now my Jenkins is going to load this credential. And what Jenkins will do, Jenkins will do a Docker login command to log into my Docker Hub account. Once Jenkins will log into my Docker Hub account, okay, Jenkins is going to build my image, push my image. They are right now building or pushing only my backend image. But now they will also build my front-end image. And after building my front-end image, they are going to push my front-end image as well. And once my images are pushed, what else they will do? They will do a logout over here. Okay. They will log out from my Docker account, which I have done. And you can see my front-end image is present. My Docker file for front-end is present under HTML folder. That's why here we have given a path. When you give dot means your current folder. Here I'm saying dot/HTML. It means for my front-end image, my Docker file is present inside HTML folder. You can see inside HTML folder. Now this step is going to configure your Docker image, and then it's also going to push this Docker image to your Docker Hub. Once this is completed, your images are pushed. Now this is the final step which is going to deploy your application to your Kubernetes cluster. Okay, and here we are going to work with some of the Kubernetes you can say Kubernetes component resources, and these resources are called as deployment services config map. What are these resources? Let's learn about them. So in Kubernetes, guys, if you want Kubernetes to do something for you, to manage something for you, in that case, you have to create some YAML scripts. In the YAML script, you have to define everything. Okay. In my case, these YAML scripts are present in the deploy folder. Okay. And to understand this script, you must have a basic Kubernetes knowledge, but I will still give you a view how these scripts are created and what exactly they are doing. Okay. So guys, just let me check whether my cluster is ready or not. It should get ready, otherwise there will be a problem. Okay, so EKS 25, waiting for cloud formation. I think my switches are still not created. Let me just go back, check the status of my clusters, what exactly is happening over there. Okay, so instances are, let's say, running. So if it would have launched some worker nodes, then I can consider that this. No, it haven't launched any worker node. It means it may take some more time. Let's wait for this to complete. Meanwhile, let's discuss about these YAML files which we have over here. Okay. So guys, now what is this? What is this file? What is deployment? So in Kubernetes, guys, we have different kind of resources available. One of the resources is your deployment. Let me take a screenshot and let me explain it very quickly for you. So you want Kubernetes to do one thing for you, that is to launch your pods, launch your containers basically. And then Kubernetes, you also want Kubernetes to also remember your let's say instruction. So let's say I'm going to ask Kubernetes, can you please launch a container for me? In this particular container, there will be one my let's say backend server will be running. Okay, in this case, it is for my front end. So I will say my front end server will be running. Okay. So in that case, Kubernetes will say, okay, why not? I can do that for you. But you will have to create one resource of called deployment. Then you have to give a unique name to your deployment. In this case, we have given a name as web. Then they're saying how many replicas do you want by default? So as per your load, you can imagine like how many replicas you want right now. If you want me to do auto scaling, I can do it. But by default, let's say I mentioned replicas as 2. I want you to launch 2 replicas over here. Then here we have a template section where we define what will be my container template, how my container should be launched. So you can see here we have defined some specification, and then we are saying that you have to launch a container from this kind of image. This is my image name. This is the same image which we have just pushed via our Jenkins pipeline. So if you go back to your Jenkins, where is Jenkins file? Okay, so Jenkins file, here's the place where we have pushed our image, right? Movie streaming backend Node.js status, or this is for front end. Same image name we are asking our Kubernetes to deploy for us. So Kubernetes is saying, okay, in which port number it will be running? I'm saying it will be running in port number 80. My front end server will be running on port number 80. Now, what Kubernetes does, Kubernetes gives unique label to all of your containers, or you can say pod. So in this case, I'm going to launch this container. Here, my front end server will be running. Okay, so Kubernetes is going to give a unique label to this particular container or pod, and the label will be app, web. App is a keyword, web is a value. This is a label. Why this label is very important? Because in future, when in Kubernetes there will be hundreds of containers created, okay, then how Kubernetes is going to manage your specific container? So in that case, label will help Kubernetes to identify that, okay, this container was part of my this deployment, and this deployment my user have mentioned to launch 2 replicas. So I will always make sure 2 replicas is always running. If any one of them is down, I will relaunch it. Okay, that's what we can do. Then here, this particular image or container we have created, it is expecting one of the environmental variable. Okay, how are we going to pass environmental variable? They are looking for some API URL. So basically, guys, this is your front end application. Front end is running in a different container. Backend will be running in a different container. So your front end wanted to communicate with your backend. So in that case, your front end needs the URL of your backend, location of your backend, where exactly your backend server is running, where exactly your Docker second Docker container is running. Okay, so here this is my front end container where my HTTP server will be running. Then I will have a backend container where my node server will be running, which has the entire business logic. So if you want your HTTP server to connect with your node server, in that case, your front end server should know the URL of your node server. And now this is something which is going to keep on changing, dynamic. I can't hard code it. That's why here you can see I haven't hard coded it. I'm using one more Kubernetes object that is called as config map. So Kubernetes, we have config map to store all those variable data which are keep on going to change. So you don't want to hard code it in your main file. It is going to keep on going to change. That's why we will put it in config map. So config map is one of the resource in Kubernetes. After today's class, guys, whenever you will have some time, what you can do, you can go and you can learn these things, Kubernetes deployment. Okay, and same thing you will be able to find out in the Kubernetes document as well. Okay, we have very limited time, so you can see same kind of deployment file they have also created. They are creating some Nginx server, but we are creating some our own server behind it is running in the Nginx only. So this is my deployment file for front end. Similarly, you will see we will have one more deployment file that will be for my node application. Here the deployment name is different, node app. Here you can see the image is also different. This is the image of my backend application. Now my backend application will need to communicate with my external systems. Like my backend application will need to communicate with my database. So you can see there is a lot of immutable variable which we will have to pass to our backend application while using it. Okay, so you can see here there are so many immutable variables we have to pass. The first is what is your database host? Where exactly your database is running? So I will say my database is running at this particular location. So I'm not hard coding the value over here, because if you hard code the value, then if that value change in future, you have to again come to this YAML file, you have to change it. So we are using one config map over here, which is working like a reference. Similarly, what is your username? Again, it's coming from a config map. What is your password? Now, password is something which I can't hard code, and password is also not a normal variable. Password is a very important thing for us. It's like a secret, confidential information. So in Kubernetes, whenever you want to store a confidential information, we have an object called a secret object. So here, this data is going to be loaded from a secret object behind the scene. So you can see I'm not hard coding multiple things. These variables are created somewhere else. Okay, I'm taking a reference of it and I'm giving a reference of it to my container. So my container will need multiple things. Where exactly your database is running? What is your database username? What is your database password? And what is your database name? Means in database in your MySQL database, once you create it, you can create multiple database. Inside database, you can create multiple tables. So they are asking what is your database name? Host means what is your database URL? Where exactly your database is running? It will have a URL. Name means your database name. Okay, that will be required. Then two more things my backend server will require. That is my access key and my secret key. Why these information are required? Because my backend server will also need to communicate with my S3 over here to upload all the raw data. And to upload the raw data, my backend server should have my AWS credentials. Otherwise, how it will communicate with it? That's why here, what I'm doing, I'm also providing my access key of my AWS account and secret key of my AWS account. And I don't want to hard code it because again, it's my confidential information. So you can see here, we are going to load it from a secret. These values are going to be loaded from secret. Then we have a reason in which region your server is running, your S3 bucket is running. So it is Mumbai. Like Mumbai region is not a confidential information, it's just a variable information. So we'll use config map. So config map is used to store all your variable information. Secret is used to store all your confidential information in Kubernetes. Kubernetes will store it in a very secure manner for you. That's why here you will see we have two more files. One is secret.yaml file. In this file, you can see this is a secret resource. It will be pointing to my password, my access key, and my secret key. Again, this information I'm not hard coding over here. This information I will give it in a different way to my secret. I will explain you about that. In my, you can say config, okay, config map. Here you can see what is my database host name. I will have to give the exact host name of my database. I have to give the exact name, where exactly my database is running. What is your database username? I have to give my database username. What is your database name? My database name is this one. These are non-confidential information. These are just like a variable. So I have defined in a config map. That is setup, guys, we have. Now let's do the practical. Let me see whether my cluster is ready or not, or what happened to the cluster. Cluster should be ready, guys. Otherwise, there will be a problem. Okay, I think they may fail after some time because ideally they should not take this much time to create the cluster. Okay. Yes, you are asking a very good question, Hitika, and I think SEC has also given a very good response for it. So we have in Kubernetes master node, whenever you will check the architecture, we have etcd data store, which stores all this information for you, which also stores all your desired information. So my desired information was to launch at least three, you can say my desired information was that you have to do one thing and you have to launch, where is that, my file? You have to launch at least two replicas. So whatever information or request I'm giving to Kubernetes, everything will be stored in my key value data store. Key value will be the one where all my requirement will be stored, and Kubernetes is going to take my requirement from this key value store, and then Kubernetes is going to implement it, apply this. Okay. So guys, looks like there is some problem with this cluster configuration now. It is taking more time. Okay, so guys, any one of you are running this cluster, if you can share your cluster with me so I can at least complete this project. So I can check my cloud formation, what exactly cloud formation is doing. So cloud formation, guys, is a template which is being used behind the scene, one of the AWS service which is being used behind the scene to launch my cluster. It is still saying create in progress. And if it take more time, it means it will fail eventually. So I will check all the events. Okay, manage notebook is taking so much time. Okay, so now this will be a problem. Okay, let me check. So we are still waiting if this can be completed. Okay, so guys, it is getting completed. I will explain you a few more things. So at least we are able to use our time. Okay, so because once the cluster is created, we just have to run it. We don't have to do anything else. It will be just a 2 minutes job once the cluster will be ready. We just have to execute it. Okay, so you can see in my Jenkins file what my Jenkins file is doing. Okay, my Jenkins file is um, building my Docker image. After building my Docker image, the third thing my Jenkins is doing is deploying it. And here you can see what I'm doing. I'm storing all this confidential information in my Jenkins. And Jenkins is further passing this confidential information while running my command. So you can see cubes. We have a command kubectl create secret command that will create a secret resource for you in Kubernetes. Then once your secret will be created, now you will apply your config map, which will apply all the variables you have created. Apply command means, guys, till now all these YAML files we have created and kept it to ourselves. As you will run the apply command, it will be applied to Kubernetes. Means in Kubernetes, these resources will get created. So what I'm doing, I'm first creating my secret. So my secret will be stored. Then I'm creating my config map, which will store all my variable data. Then I'm deploying my backend node, the backend node. Then I'm deploying my service of the backend node. Okay, what is service over here? So you can see we have one file called as service node app.yaml file. Service is again one of the resource in Kubernetes, very important resource. Anyone who was thinking about load balancer till now, service is the one which will give you this particular feature in AWS, sorry, in Kubernetes. So let's take a scenario. Here I have launched 3 containers for my front end. Means in 3 containers, my front end application is running. Then let's say for my backend application where I'm running Node.js, I'm running backend over here, Node.js. Okay. Here also I'm running 3 containers, or let's say 2 containers. In 2 containers, my backend Node.js server is running. They are exact same copy of each other. Why have we launched 2 of them? So that we can we can distribute the load between them. Okay. Now, whenever my front end will need to communicate with my backend, how will it do? So here, each of these containers will have their own unique IP address. This one will have their unique IP address, let's say 172.17.0.3. This one will have an IP address, let's say 172.17.0.1. So if your front end wanted to communicate to your backend, your front end must have the IP address of your backend. Then only it can communicate. So in this case here, let's say if I have hard coded in my front end that your IP address of your backend is 172.17.0.1, so my front end will be able to communicate like this. This is my replica of front end, means this front end container also have the same code. So this will also get the connected to this. This one will also get connected to same container. So here we are not able to distribute the load because we are hard coding the IP address over here. And IP address is a very dynamic thing because if this container got deleted, let's say there was some memory leakage, this container got deleted. So my Kubernetes is giving me a responsibility and giving me a confirmation as well. That I will make sure always 2 containers are running. So Kubernetes will automatically create a new container. But this new container will have a new IP address now. So you will have to again go to your front end and you have to update manually the IP address over here. And that is a very big problem. Why? Because your systems, your containers will keep on getting created, they will keep on getting destroyed, and then their IP address will keep on changing. So how will you do a mapping with your front end? That's why for their communication in between them, we will need a service. Okay. So here is my front end. Let's say here there are three pods are running for my front end. They are each replica of each other. Okay. Here is my backend running where my Node.js service is running. Let's say I have two pods running over here. So in between them, I will configure one service over here. And this service will be mapped with your all the backend system. And this service will give you a static IP address now. And this static IP address you can give to your front end. So what your front end will do, front end will only hit to this particular service. And this service will be doing the load balancing behind the scene. Kubernetes service will do the load balancing behind the scene to distribute the load between these two pods. Sometime the request will be sent to this container. Sometimes this will be sent to this container. Let's say we have more load. They have launched more containers over here. Third container, fourth container. Again, automatically these new containers are created. They will automatically get attached to your service. And now your service will also divert the traffic to these four containers now. So the question here is how service will get attached to my containers because their IP address will keep on changing. So here we use the term labels. Okay. So while launching your containers, you can see here we have given a unique label, app web label. So each container which will belong to your let's say backend system, so they will have a different label. I think the label for the backend I have given as what label I have given? The label I have given as node app. Okay. So here each backend container will have a label app node app. This one will also have a label app node app. This one will also have a label node app. This one will also have a label node app. So your service is not going to connect or not going to identify them via their IP address. It is going to identify them via their label. So in service code, you will see where I have defined my service for my backend application. Here I have defined a selector over here. I am saying service, you have to select all those containers or pod which has this particular label app node app, and you have to put them under you. You have to connect with it. And we have a protocol also defined. We are saying anyone, this is like a port mapping we are doing. Anyone who will come to you, this service, at port number 3000, you have to forward that request to these containers, where in these containers also the program is running at port number 3000. And we have said you have to do load balancing over here. So now my front end don't have to remember the IP address of your backend server. Without remembering this, your front end will make requests to the service, and its service is going to distribute the traffic between your backend worker nodes. That's what is going to happen over here. Okay. So the service will help you to have a communication between your different microservices. So you have one microservice, it want to communicate with other microservice. Now for other microservice, there could be hundreds of pods running. This microservice don't know what is the IP address of all these pods. So in between them, we have a service. They are going to connect with this service. Service will give you a unique IP address or DNS name. And via service will route you to these individual containers. That's what we will be doing over here. Okay, that's how you can see service is created. Similarly, there will be one service for your web application as well. Why? Because for web application as well, for my front end as well, I might have multiple pods running, and my end user who is going to use my application, he can't remember the IP address of all my front end pod. So here also there will be one service. So my end consumer is going to hit to my service, which will give him a unique IP address or DNS name. DNS name could be, let's say, sudhanshu.com. As he will hit sudhanshu.com, it will go to my service, and my service will distribute the traffic between these three pods. And that is how guys load balancing will happen over here. So you have multiple replicas running, and the load will be managed between them. Okay, load will be distributed between them, you can say. Is it clear till now? If it is, then I think now we are in the edge of deployment. Guys, don't draw anything on my screen. It is still taking some time, I think. Guys, it is taking some time. So let me do one quick thing, quick step. What I will do, I am going to create this entire server, Kubernetes server on my local system, on my virtual machine itself. So initially I was thinking to create an EKS cluster. That will be always better. But because it is not getting completed so quickly, so I am going to do one small change over here. I am going to create a mini kube cluster. Okay. Minikube cluster means this will be a small version of Kubernetes which you are going to create in your virtual machine itself. Here, both your master node and worker node will be running. Okay, and this Minikube cluster will give you a basic kind of setup. Okay, a basic Kubernetes, whatever Kubernetes provide you, same feature Minikube also can provide you, but it's a single node cluster. It's not a multi-node cluster. EKS was a multi-node cluster, but I think my AWS have some problem and they are not able to launch my EKS cluster. They are getting failed in some after some time. Okay, so I have only one option left now to go back to one of my repository, and now I'm going to configure a Minikube cluster that is a small version of Kubernetes you can imagine. Okay, so I will go to some of my repository and I will copy the command to configure Minikube cluster. I'm going to this particular repository. So guys, I think this class will extend for few more minutes now. Okay, so I hope you all want to complete this practical. We were waiting for it for a long time, so let's complete it. Okay, let's. So guys, this is the command which you guys can also follow to configure a Minikube cluster. These are the steps which I have defined over here. Okay, so in this particular repository, let me just share it with everyone. Okay, so I'm going to copy this first command. Okay, and then I'm going back. I'm going to execute this command. So what it will do, it will download Minikube for you. Once Minikube will be downloaded, okay, then it will also start Minikube server for you. Once Minikube server is started, then now we are going to install kubectl for us. Kubectl is again the command line tool which help us to communicate with your Kubernetes server or cluster. So I don't think it is going to be successful because it is running on 38 and now it is 9. Okay, it's almost 30 minutes. So it will not work. It will fail eventually. So let me launch a Minikube cluster. Okay. So let's create this Minikube cluster. This Minikube cluster is also, you can see, installing Kubernetes behind the scene. Once my Kubernetes will be set up, we are going to do rest of the things. Meanwhile, this is getting running. This is running over here. Let's do some setup in Jenkins as well. So guys, if you want your Jenkins to work with Kubernetes, okay, and here I wanted to work with in our case we want it to be integrated with Kubernetes. So what I will do a couple of things. Okay, first of all, I will go to manage Jenkins, and here you can see we have an option of credentials. So whatever confidential information you have, you can put all this information in this particular credentials, and these credentials will be taken care by Jenkins. Jenkins will take care that they are stored in a secure manner. So I'm going to add credential over here, and I'm going to create and store all the credential for me. And my credential type will be secret text. You can have username and password, secret file, secret text. In my case, it is secret text. Then what is your exact secret data? You can put it over here. So I have so many things, secret data which I have to store. So I will go back to my Jenkins file for a second. So the first thing which I need to store is my Docker Hub username. Okay. So here I have defined one credential ID. Copy this credential ID. So this is the credential ID via which your Jenkins is going to load this credential value from your Jenkins. Okay. So I'm going to copy this. I'm going to go back here. I'm going to give the ID as Docker Hub username and description also as Docker Hub username. And now here I will give my exact Docker Hub username. Okay. What is the exact value I have, I will paste it and then I will create it. So you can see one credential is created, which has my Docker Hub username. I will create one more. And here I'm going to again use a secret text. And let's say here I'm going to store my Docker Hub password. This is a keyword for that, which my Jenkins is going to take. I'm going to copy this. I'm going to paste it. ID will be Docker Hub token. Description will also be Docker Hub token. And then here I'm going to paste or write the exact my Docker Hub password. Similarly, in your case, you can write your password. We are writing this password because my Jenkins pipeline will take these values, will log into my Docker Hub account. You can see it is going to gather these values from your credentials, load it, and then use the Docker login command. So we are not doing any hard coding over here. Okay. What will be the next thing? After this, we have to also store our database password, our MySQL database, which we have created on AWS RDS database. That password also needs to be stored. This is the credential ID for that. So I will go back, I will add one more credential, and then here I will mention secret sorry, secret text, and then I will say this one, and my database password which I have set while creating my RDS database was this one, and I'm adding the password right now. I have added my password, secret data. Now what else I have to add? So they are saying you have to also add your AWS access key and secret key, because this will be used by your backend application to communicate with your AWS S3 bucket. So here I'm going to give this ID, AWS access key, and here let me choose the type would be secret text, not username and password. Okay. And now I will paste here my exact secret data, my exact ID. So what was the ID? Let me go back to my AWS cloud. Here I will copy my access key. I will paste this access key. And guys, these credentials will be securely transferred to your containers when you will launch them via Jenkins. Okay. So as a secret text, what is the next one? I have a AWS secret key as well. This is the last one, I think. So let me just give the ID, and then now let me paste my secret key. This is my secret key. Copy it. This key will be used by your backend application. So all these environment variable which I have defined will be used by your backend application behind the scene, okay, to connect with your database and to connect with your, you can say, AWS S3 bucket. This is one setup, guys, which you needed to do. Now, one more setup which you need to do over here is whatever S3 bucket you have created to store your data. Okay. So I think I may would have defined one more variable where you can give your exact bucket name. So in this case, you're using a bucket name GFG workshop day 3, right? So you will have to go to your code, app.js code. In this code, I think the bucket name is currently hard coded. I think the variable is not present right now, or the variable was here. I forget. Okay, let me check in the Docker file. It was not there. So let me go back to my app.js file. Okay, so here you can see somewhere I have hard coded my bucket name. Yeah, here I have hard coded. You guys can make it dynamic also. Right now, I think I forget. I have hard coded it. In my case, I have given this bucket name because this bucket name is already present in my AWS account. In your case, you have to come to app.js file. In line number 69, you have to update this bucket name with your bucket name, what you have in your case. So in my case, you will see this bucket I already have GFG movie bucket Sudhanshu blog. This bucket I already have. You can see movie bucket Sudhanshu blog. This already have. Let me delete all the data which I already have over here from my older execution, so that everything will be from beginning. So I'll delete it. Delete the objects. So now my bucket is empty. So I will not add any data directly to my bucket. My backend application will be doing it. That is the one change which you have to do. Once your credentials are ready, now go back to Jenkins. Okay. In Jenkins, go back to your dashboard. And now I'm going to create one more pipeline. So I'll say new item, and I will say my movie application. And then you can go back to pipeline section, click on OK, and then your pipeline will be created. Here they will say that what is your pipeline script. If you want, you can copy your entire Jenkins file, which I have created over here. You can copy this entire Jenkins file, Control A, Control C, put this Jenkins file over here. If you want that your Jenkins will automatically read this file from your GitHub, in that case, you will have to, okay, you'll have to use a different mode over here, pipeline script from SCM. Okay. So here I'll select pipeline script from SCM, means please load the pipeline script from my Git. And then they are saying, you are not giving me the pipeline script directly over here. You are giving it from my GitHub. Okay. I'm saying, yes, I'm giving you it from GitHub. Can you please go to my GitHub? This is my GitHub, movie streaming app DevOps. Let me copy the ID from here, my GitHub exact location. I will give that over here. Then my GitHub repository is currently public, so I don't have to give any credentials. My branch name is, I think, main. Then I'm saying that please go to my repository. In my repository, you will find a file called as Jenkins file. And in this file, you will automatically find out all my pipeline scripts. So I'm not hard coding or putting that pipeline script manually over here. I'm saying that can you please load it from my file itself. Okay, Jenkins file. You can save this. Now there's one small change you have to do. One more change you have to do. If you remember, we have configured one RDS database over here. This database have given you a unique endpoint This is a unique endpoint which this database have given to you. Database -2, something like that. Copy this unique endpoint. Okay. Go back to your worker node. Any of your system you can go, that is fine. Okay, where is my other system running? Let me just go to that system. I can imagine, guys, this is so many steps. It's not so much simple. Yeah, you can say it got failed. But anyway, I have created a mini cube cluster over here, so I will be able to at least okay do something. So my kubectl is working right now. So what I will do here, I will do a MySQL query. I will try to connect with my MySQL database which I have created. Okay, this is a database I have created. My username was admin, and then I will give my password over here. But they are saying MySQL command is not present in your repository, sorry, in your virtual machine right now. Do you want to install it? I'm saying yes. So guys, in Yum, we have a command, what provide command. And then we can give the exact command name. Let's say I wanted to know which software provide me MySQL command. They are saying that there's a software called as MariaDB in Amazon, which is present. Can you please install this package? This package will help you to install MySQL command. Guys, why I'm doing it? Because in my MySQL database, I have to create a database over there. And once that database is created, then only we can proceed ahead. So now I will again do the login command. Sorry, not this one. This command. I will give the password. I will give my database password. And you can see now I'm inside my MySQL DB. This is the same MySQL DB which I have created in my RDS. I'm able to connect with it. Now here I'm going to create one database. Database. What database? The database which my application is going to use. So here in your application, you will see there is one file config.yaml. By default, I have mentioned database name as MovieDB. Okay, so I will copy this name and I will give this name over here, MovieDB, and I will create it. Okay. Then I'll say, can you please show me? These are SQL queries, guys, which I'm right now writing. Databases. Okay. So you can see one database, MovieDB, is now been created, which will be further used by my application now. That's the one thing we have done. Second thing, what you need to do, you need to copy this particular endpoint information of your database, go back, okay, and then here in your config map.yaml file where you have defined all the variable data, okay, so I have to come back and I have to update that my database URL is this one. My database endpoint is this one, okay, and then you can commit these changes. Guys, that's it. I think we are good with the entire setup now. Now we can go back to Jenkins and we can trigger our Jenkins pipeline. And let's see what Jenkins will do. Okay, so I will trigger on my Jenkins pipeline. Jenkins will be triggered. Okay, you can see the Jenkins pipeline has been triggered. We'll click over here. We'll go to pipeline overview. Okay, and we'll see what all Jenkins is doing. You can see Jenkins has first of all check out my code. Now Jenkins is trying to perform unit test cases, unit testing. Okay, so here you can see Jenkins is right now installing Node.js as we mentioned in our Jenkins file, Jenkins script. And then once this Node.js will be installed, they are trying to install all the Node libraries. And once it will be also done, then they are going to test my test cases. So you can see all the steps will be now done one by one. Okay, one by one, each of them will be completed. Okay, there will be one small setup. We will have to do it manually because if we would be using Kubernetes EKS cluster, then it would have been more easy for us. But because right now I'm running my Kubernetes cluster in my local virtual machine, so I will have to do some extra setup today. So let it complete. It may fail after some time. I will show you, and then you will have to update it. So Docker build and push we are doing right now means unit test cases are completed. So if you want to see the logs of a particular job, click over here. They will show you that my test cases are working fine. Okay. All test cases, I have given a very small test case. Test cases are working fine. Okay. One test case currently has been passed. You can add more test cases if you want in your application. Now what they are doing, they are trying to build my Docker image. And you can see I haven't hard-coded my Docker Hub username and password anywhere. I have defined all my credentials in a separate place in my credentials section of Jenkins. So what it will do, it will load my credentials. And you can see they were able to log into my Docker Hub. Now they're trying to build my Docker images. Once they will build the Docker images, they are going to push these Docker images to Docker Hub. Okay. And then we will be good, right? So in some time, what you will see, my Docker image is currently getting built, and once the build will be completed, it will be pushed as well. You can see the image is now getting pushed over here. They are pushing the images. So this image will be pushed to my Docker Hub. So if I go to my Docker Hub, hub.docker.com, okay, so everything is usually being done via this pipeline. Okay, so let me log into my Docker Hub. And guys, I really appreciate that you guys are still in the meeting. You are still keen to learn. Okay, so I appreciate it. Okay, I could have shown you a very small project for this Kubernetes. A very small project would also have worked, but I wanted to show you something big, and I think this big is taking so much time, right? So please bear with me for a few more minutes. Let's complete this practical. And I hope if you add this practical in your resume, it is going to help you a lot because we are using almost everything over here. You can see just less than a minute, my two images are uploaded. One is my front end image, one is my back end image. Because I want to launch two containers. In one container, my front end application will be running. In one container, my backend server will be running. Okay. So if I go back, see what else is happening to my Jenkins right now. So Jenkins, you can see after push the images, they have removed all the login credentials for security reasons. Okay, that's what they have done. Now here they got failed. In deploying to Kubernetes, you can see some of the steps were passed, but here one of the step got failed. And this step got failed because this step will work only when you have a load balancer setup being done. And right now, because we are doing it locally, we are not using AWS EKS cluster. So my load balancer was not created. That's why it got failed. So I will have to do a small modification over here, guys. I will go back to my worker node. Okay, worker node. Where's my worker node? Okay, this is my master node. This is my worker node. Here we have installed kubectl, and here we have our entire mini kube cluster running, guys. So if you see Docker PS, what you will see right now, I am running here one more container. In this container, my entire Kubernetes cluster is running. You can run this Kubernetes cluster in your base system as well. Initially, I was trying to run this Kubernetes cluster on AWS EKS, but now we are running it in your Docker as a Docker container to make it very quick. And here, these are the command kubectl get pods command. This command will tell you how many pods are running. You see, only my backend pods are running. My backend containers are running. My frontend containers are not running because of a small failure. Okay. Load balancer is good. Okay. In this case, load balancer failed because I'm doing it in my local system. I have a fix for that as well. So don't worry. We have a fix for that. Okay. If I do kubectl get service, this will tell me how many service I have created. So you can see here I have created a service with, and I have given a type as load balancer. And because I give a type as load balancer, usually they give an external IP address. Okay, external DNS name basically. So I was initially thinking to create a load balancer on AWS cloud. So when you create a load balancer on AWS cloud, they will give you a unique DNS name. In my case, we are doing it in local system, so they haven't found any external IP address, so it is currently in the pending state. And in my Jenkins file, I have added a small script. If you see in your Jenkins file, I have added a small script to retrieve this particular load balancer name. Okay, so here after that, what it will do, it will retrieve my load balancer this load balancer external IP address. It will retrieve over here. Okay. In my case, it's not present, so I will have to do it in a different way. Okay, we'll have to do it via node port. So guys, this is like a port mapping you can imagine. So currently in my base system, in port number 3000, okay, anyone if you will hit to port number 3000 of my base system, you will get forwarded to this particular port number of my container. Or you can say this particular port number of my service. So this is my service, okay, which I have created. You remember this is a service we are talking about. So this service may give you an external DNS name as well. That's what we were thinking earlier. But now because we are not doing it in local system, we can't have a DNS name over here. So what I will do, I will say to anyone who wanted to connect to this particular service, okay, they can connect to a unique port number. Which port number? This port number 31463. So we are saying anyone who will come at port number 31463 of my node, Kubernetes node, then they will be able to connect to my service. Okay, so guys, the setup will be little complex now. Okay, So I have to do a small change. I have to create a small socket over here to make it work. Okay. Dev null, let me install socket. So guys, the main agenda, if any one of you is interested what exactly is happening technically background in a background, so I will show you. Okay. So the thing is, my setup is a little bit changed now because EKS cluster didn't work. Okay. So now this is my EC2 instance. In this EC2 instance, I have created one more setup that is here your Minikube cluster is running. Minikube Kubernetes cluster you are running. And this Minikube system will be also having their own IP address. In this case, the IP address of this particular Minikube cluster will be 192.168.49.2. Inside this, I have created one service, and this service map you to your multiple pods, multiple containers, your backend containers. So anyone who wanted to connect to the service, if they are part of my Kubernetes cluster, they can directly connect to the service internally. But right now, my user is outside of my EC2 instance. If your user is inside your EC2 instance who wanted to use this service, so what they can do, they can connect to your node, your Minikube node. At this node port, the node port over here is 31463. 31463. So if you connect to this Minikube at 31463, you will be able to divert or connect to this particular service. This is a concept which works behind the scene. But right now, I am outside of my EC2 instance because if I do Minikube IP, you can see my Minikube has this particular IP address right now, 192.168.49.2. Okay. In my EC2 instance, I don't have a web browser. And to use my web application, I need a web browser. Okay. That's why I will have to connect with this particular service from outside of my EC2 instance as well. Because from inside of EC2 instance, if I will try curl 192.168.49.2 at port number 31463, you can see I am able to connect to my Nginx. Sorry, not to my Nginx, to my Node.js server. But here in my EC2 instance, I don't have any browser. My browser is there outside of my EC2 instance. So here I am getting one extra socket. Okay. This is again like a port mapping. So my user will be outside world. They have to connect to my public IP address of this particular EC2 instance at a port number 81, let's say. And then they will be mapped with this particular port number where your service is running. And this then finally you will be able to reach to your service. This is a you can say more complex networking setup we have to do to have a connectivity of this service from the outside world. Okay, that's what we'll do. So guys, this class will go for few more minutes. So until I complete this practical, I will take this class. That's it. So because I have to close it. Okay. Although for this workshop, the agenda was to cover only basic things for all these technologies. I tried my best to go a little bit deep into it, and that's why we are taking some extra time. Okay. So guys, I will take some more time. Okay. So now I will do one thing. I'm going to create one socket over here. Okay. Once after completion of this class, I will show you one document as well about the entire setup I have done. So after the class, if you re-watch this video and if you again go with the document which I will share with you, you will be able to do this setup. You will be able to understand the setup. Because don't think that this is very complex. It's very simple. You just have to invest some more time to understand this. Okay. Now I'm going to create a socket. Socket will be something like that. TCP4. Listen, I will explain you what this command exactly does. Let's say any port number 83, for example, 83. Okay. And then I will say fork nobody and TCP. Okay, 192.168.49.2. And my port number will be 31463. 31463. What this command is doing. If anyone wanted to understand this command, so guys, I am creating a socket over here because I don't have access to connect with this service from the outside world. So I'm using a trick over here. I'm saying I will connect to my EC2 instance at port number 83 in this case. Then EC2 instance will take me to this particular service. You can see we are saying I will be listening at port number 83. Fork means that I wanted to accept multiple parallel requests. And then nobody means that whosoever will log in or will connect via the socket, they will have a very limited privileges on my system. And then whosoever will come to port number 83 at my base system, they will be forwarded to this particular IP address. This is your node IP address where your Kubernetes cluster is running, and they will be forwarded to this particular port number 31463. That's it, guys, which we are doing over here. Okay. If we do this, and if we start this socket, whenever you wanted to start a program in background, you can use and symbol behind the scene. And as I will enter, this socket will be started. Now I can copy this IP address and I can hit to port number 83. I will be able to connect to my service. You can see I'm able to connect. Although they are saying this is not a correct path where you are connecting, but at least they are saying cannot get. Okay, means at least I'm getting some data. I have a connectivity over here. I'm not currently connected to the right endpoint. We have one endpoint which is defined in the code is movies endpoint. And this will tell you, okay, the what all movies are currently being stored over here. Okay. So in my case, they are showing me that two movies are already there. I think I may have connected to my older database. My older database already had some data. That's why they might be showing me this. In your case, it will be empty data. It will be completely blank. Okay. So I am able to connect to my worker node. Guys, you all are free to leave this class. It's not compulsory for everyone to be there until last. I'm just trying to close this practical. If you are interested, if it looks interesting to you, be there in the class. Otherwise, you can drop. That's completely fine. It's not compulsory. Like no one is asking you to sit over here. But I will recommend my personal preference would be you. If you be here, you will be able to learn something. Okay, otherwise, you guys can drop. That's fine. So that's the first thing. My backend is now running in a particular port number. And this is what we have configured over here. I can copy this. Now I will have to make a small, one more small change. Okay, I know this is getting now more complex because if our cluster would have worked EKS cluster, it would be very simple for you. Just in one click, everything would have been done because I have created my Jenkins pipeline in such a way that it will work with an EKS cluster. But it didn't work today. So we have to now look for some alternate steps. And that's why we are doing right now this. Let me go to the data folder. Here you can see we have a workspace folder. Right now I'm in my worker node. In my worker node, I have created one pipeline in Jenkins. That's why in the worker node also you can see that the directory is present. I will go to this movie app. Sorry, my movie app. And here if I do ls, I go to deploy. So whatever scripts I have created, YAML scripts I have created, I will have to do a small change in them, you can say, to make it work. Okay. One of the change which I will have to do is in my one of the file, web app config file. Okay. And in this case, here I will have to define that right now my backend is now running in this particular IP address. Okay, so in this particular IP address, my backend is running. So I have to define over here that my backend is running at this particular IP address over here. This is the first thing I'm going to do. Okay. Once I do this, I'm going to apply this change. Okay. I will say that I will apply this. Let me do one more thing. While getting this socket to make it work, let me give the same port number because usually it works at port number 3000. So I'm going to give 3000 port number over here. Let me check the changes which I have done in web app config.yaml. I have given the right IP address now. Let me do kubectl apply -f. Whenever you wanted to apply a YAML file, you can use kubectl apply command. And then I can say, I have a web app config.yaml file where I have a config map, which I wanted to update with a particular value. And then this will be updated. Once this is updated, what else we will do? So guys, earlier we were supposed to do all these things via Jenkins pipeline, but our Jenkins pipeline failed at a particular step because of a difference in the EKS cluster configuration and our local configuration. So now I have to run this command directly from here. But if you want, I will update my Jenkins file as well after this session. So after this, you have to just run these two commands. These two commands were left. Only this part failed for us. These two commands we have to just run and our application will be successfully deployed. Let me copy this command. Okay. And if we run it manually right now, because I did a small local setup. Sorry, I have to just give my deployment web name directly over here. I am already in the deploy folder. And then let me copy this one. So that my service, my web app service can be used from the outside world. So I'm going to apply this one as well over here. That's it. Now what you will see, guys, our setup is done. Okay, so what we were looking for from such a time, now it should be working. Okay, if you wanted to check, so you can see my one more service is now created. This service is created for your web application where your front end will be running. So your user will never connect to your backend directly via APIs. Your user will always go via front end. Okay, so what you need to do now, you need to expose this particular application via socket as well, so I can use it from my browser. So I will again use a socket command. The only difference this time will be that socket command, there is a program running at this particular IP address. This is my minikube IP address at port number 32756. Let me use it 32756. And I want anyone in my system who will come to port number, let's say 8080 of my base system, they will be able to connect it. So now let me copy this IP address and let me check if it works. I'm able to connect my front end or not. Or we have still some issue. You can see it's working fine, means now we are able to connect to our front end application. Okay. If you remember in our front end application, we have created multiple files over here. One of the file was register.html, where you can register a particular movie, right? Where is that? Register.html. So now if you want to register a movie, just have to come back here and hit to /register.html. And this is the web page. It will prompt you where you can register a particular movie. This was the main application, guys. So our application is now running in Kubernetes cluster, okay, in a containerized manner. The main agenda of this application is you can register a particular any kind of movie over here. You have to give a title, any title, let's say my GFG movie or whatever. Okay. Even I'm giving this to you as well. If any one of you also wanted to upload any kind of movie, video, any kind of video, you can take sample video, you can take, you can upload over here. Anyone of you can do, and everyone will be able to see that content. That's the main thing. Then what is a movie genre? So movie, okay. So here, my genre would be, let's say, action. What is a movie description? Let's say any South movie or something. Okay. And then what is the movie rating? I can just give 10. These are some normal values. These all values are going to be stored in your MySQL database. When this movie was released, again, this is a normal value. I'm going to give this one. Now, here is the main part. What is your movie poster? I'm going to select here and I'm going to select something. Let's say I'm going to select anything. I have Avengers right now image available. I will select Avengers. Then what is your movie video? Now, here you have to upload the video file, raw file, MP4 file, which has your entire movie. You can upload any file. In my case, I have this Avengers movie. I will open over here. That's it, guys. That's it. As you will click on the submit movie, what will happen? Your front end will communicate with your backend behind the scene. Okay. And your backend will communicate with your database, and in your database, it will store all the metadata. And you can see I've got successfully, my movie registered successfully. It means everything is being registered properly. It means in my database, the data is being registered. And these raw data, JPG file and MP4 file are being uploaded to my S3 bucket behind the scene. So you can see it is successful, means we are good. Now, if I again open this particular website in a new page, and if I select for gallery.html, so what you will see, you'll be able to see all the movies which I have right now or till now uploaded over here. So guys, I think while configuring my database, I might have configured my older database. That's why some of the some of the information I had in my database, older database, that's why they are still visible over here. But this is a movie which I have just added, right? Similarly, if you guys will also add something from registered movie section, then that will also be start visible over here. And if you see, if you go back to your S3 bucket, so in your S3 bucket, the files would have been stored. So if I go back to S3 bucket, last time it was empty. As I will refresh, you can see two files are present. One of them is MP4 file and one of the JPG file. If I open this MP4 file, so I can see this MP4 file is present in my S3 bucket. And this is how this file looks like. Currently, I will not be playing it from this kind of S3 bucket. I will be playing it from my application. As you will click on the watch, this kind of application will open where you will be able to watch it. Now this video is loading from your S3 bucket. From S3 bucket, behind the scene, your application, your node application is calling the S3 bucket. You can see whatever video was stored over there, I'm able to do it. Okay. So this is a very simple thing. Okay. And whatever metadata about this entire information would have been stored in my DB which we have configured. Okay. So I have to check what DB I have mentioned in my config map. Okay. This is the DB which I have mentioned, database 2, I think. So ID database 2 should have been used. So if I go back to my DB, I will be able to see the same kind of data. Okay. And if I go back to my register movie, let's say I will update some more things, let's say ABCD, some new movie, let's say comedy. Okay. And it is dynamic, it's completely dynamic. So I can update as much as I can. One, let's say 2023. Now I'm going to again upload some other different kind of folder. Okay. Let's say I'm just going to upload one LAN image over here. You can upload some good folder image. And then if I upload any of I have some small videos available. I will click on open. And if I just do you network tab, just show you what kind of API call is happening. As I will click on submit movie, you can see my backend application will be called. So my front end application is calling my backend application. Okay. Backend means my Node.js is running, and my Node.js is the one. You can see it took some time, and after that, it has given me 201. Means the movie was registered successfully. Means one more movie I have registered. If I go back to my watch movie section, okay, so I will be able to see this newer content as well, the lion image, and I have uploaded some random comedy I mentioned, 2022 I mentioned. So whatever video I have uploaded, some random video I have uploaded, so that video will also be visible over here. Some dog image I have uploaded, so it's visible. Okay. So your entire data will keep on getting stored in your DB. Okay. And other things will be stored in yours. You can see if other things will be stored in your databases. In your database, all the metadata information will be stored. Okay. So if you go back to our database, where is our database? We took it somewhere, right? Let me go back to my AWS cloud. So guys, just one more minute. I think we are almost done now. So anyone have any queries now? You can ask me. So now, because we are done with the practical. So if you have anything, you can ask me. Yes, the website which I was like currently we are not using SSL certificates. So yes, it is not protected. Currently, it is in insecure mode. If you wanted to run it in protected manner, in that case, you will have to add some SSL certificate. That is again a different concept. If we go in that direction, then I will need 1 more hour to complete it. Okay. So you are saying that Kubernetes is creating a new Docker container for a particular service on load. Yes, but it is good practice to launch all these Docker instances on the same instance. What if the whole yes, that's what that your Kubernetes will take care of it. Okay, so what Kubernetes will do? Kubernetes will is very intelligent. If you have a multi-node cluster, right now I have configured single node cluster for just quick practical. Kubernetes will always distribute your pods. So what Kubernetes will do? Let's say I have 4 worker nodes running over here. This is your Kubernetes master node. Let's say you have 4 microservices. One is I'm running with a black color. That is your let's say cart service. One is let's say your catalog service. One is your some other service. Guys, again, don't draw anything on my screen, please. Okay. So what for the card service, it is not like Kubernetes will only create all the pod for the card service in the same virtual machine. Some of the pod will be or container will be created in other virtual machine as well. Kubernetes will always take care of distributing them. In Kubernetes, we have a scheduler. Scheduler is the one who takes care where exactly your container will be scheduled if you have multiple worker nodes. Scheduler take the decision. It keep on doing the balancing. So it will always launch your containers equally in your worker node if you want. So you can say, Kubernetes, I want you that if I have 5 worker node, equally you have to distribute my container of card service to all the 5 of them because card service is very important for me. I don't want a single point of failure. So we can do that. It's possible. In Kubernetes. Okay, I hope it is clear to you, Sarat. Anyone else have any doubt? Okay. Meanwhile, I was just going to my database. I was just going to my worker node as well. I will say what was the command? MySQL -h, that is my host name, and you admin, and then I will say my password. So I'm going to connect my database. Now here I will say, do you have any database? They are saying yes, they will have a database, movie database. Okay, sorry. Okay. Okay, so what happened? So databases. So you're saying yes, movie DB is present. I will say, please, can you use movie DB for me over here? Okay, what happened again? The spelling of movie DB is wrong. Movie DB. So you can say I am inside movie DB. Now I can say, can you please show me the tables which are present over here? They are saying yes, we have a table, movies table. So if I say, can you please show me everything stored in this particular table, movies? Okay, so you can see a lot of things are currently being uploaded. You can see someone has uploaded learning DevOps. Thank you, sir. In your this kind of MySQL application, and you can see here that we have a schema where we are storing video URL. Okay. Similarly, we are storing the image URL as well, thumbnail URL as well. So you can see where is my video URL? My video URL is coming from my bucket. The rest of the metadata is keep on getting stored in your DB. Okay, that's what is happening over here. So if I go back and watch movie, if I just go one back and if I have over here, other things I can see. Okay, and I will be able to watch it. I think it will crash if it's not been properly handled. So it should be MP4 file. If it is MP4 file, it's an MP4 file, so I can play it. Okay, that's all, guys. I think we took a lot extra time. I'm not sure if you guys have took your dinner, but that's all for this particular workshop. I wanted to show you this particular training where you know how to start from development and how to do a deployment. Okay, via help of Kubernetes and all these tools which we have discussed in our journey. Okay, so DevOps is a very vast role, big role. Okay, a lot of things DevOps have, but I tried my best to complete or to show most of the topics which can be completed in this limited time. Okay, if still anyone have any doubt, you can always reach out to me directly on my LinkedIn. You don't have to hesitate. Reach out to me on my LinkedIn. With whatever questions you have, I will try my best to help. Okay. So so this whatever I have provided training, it will always be present in YouTube. You can go to Geeks for Geeks, go to live section. There you will be able to find the recording of day number 1, day number 2, and day number 3. Whatever practical we have done in AWS, most of the services are free. Only when you will use T2.medium, it will have come up with a very small charge, but still AWS ignore it. So whenever AWS gives you a charge, what you can do, you can write a mail to AWS and you can try to convince them that you are a student, you are not a company, you are trying to do some practicals. So I have seen that AWS people have a good heart, and most of the time they will remove that bill from your account. Okay, so do the practice, and then after your practice, please remove everything, delete everything. Yes, so Sarad, the command which I was trying to run initially, if you guys can try to run it. In my case, I think because I have created so many EKS cluster in this month, just in May. That's why my free tier account or limit would have reached. That's why they haven't launched or they were not able to launch my cluster. So Sarad, what you need to do, go to your README file. In the README file, the command which I mentioned, okay, if you run this command will configure the entire master node for you, as well as this command will configure the worker node for you. As well as this command will also configure auto scaling group for you, where If you have multiple worker nodes, if any of the worker node is down, it will launch more worker node. If you have more load, it will launch more worker node as well. So worker node will also be launched more as per your load, and Kubernetes will take care of launching more and more containers as per the. This is the command which will configure the EKS cluster. If you run this command in your case, it will create your EKS cluster in one go. Once your cluster will be created, whatever commands I was doing it from my command prompt, I was using kubectl command. Similarly, you can also use kubectl command from your end. Okay, so you can go back to your EC2 instance. Where is my EC2 instance running? Where is that running? I forget. Yeah, here. So you guys can also come back. Let me exit from my database right now. So you can also run kubectl command. You will be able to run it. The only difference is right now my container is my cluster is running Kubernetes cluster is running locally. In your case, if you hit to EKS, okay, EKS, then here your cluster will be running in EKS service. And then you will see two worker nodes will also be running. And those worker node will be your virtual machine. So if you go to your AWS, in my case, cluster is running, but my worker node was not getting launched. That is the problem. So worker node will be visible to you in your EC2 dashboard. In EC2 dashboard, you will be able to see that two worker nodes will be running, and this worker node would have some agent running to connect with your EKS cluster behind the scene. You will be able to see it. And once your cluster is created, you have to run a command EKSCTL delete. This is the command you have to run. Otherwise, a disaster will happen. A lot of cost you will get. Once your cluster is created, you have done the practical. Please remove it. EKSCTL delete cluster hyphen name. Give your cluster name and delete it. Delete that cluster. And whenever you will delete the cluster, it will delete everything. Your worker node, your auto scaling group, any load balancer it has created, master node, everything will be deleted. Okay. So anyone else have any queries? Thanks, guys. Thanks for your words. Okay. Okay, guys. So that's all I think. We may meet in any other training. So I provide training in DSA as well. So if anyone of you are aware about DSA, work with DSA programming, I provide it. If you work with mobile application development, so I provide training on Flutter as well, Flutter frameworks. Okay. If anyone of you work with cloud, so I provide dedicated training for AWS cloud, and I provide training for machine learning as well. So if anyone is of you is aware about data science and you want to learn in that field, then I provide training on that as well. Okay. So guys, we may meet in any other training later at a later stage, but that's all from my end. And I wanted to conclude till here. And a good luck to all of you. And thanks for joining this session. If you're stuck somewhere, reach out to me directly on my LinkedIn. I will try my best to help. That's all. And thanks. Bye. And good night. And you guys can have your dinner now. Bye.